All right, we should be good to go. Welcome, everybody. I don't like that my microphone casts a shadow. Is it from this light? I think it is from that light. So like if I did this, then maybe, but then I have to talk so loudly. I mean, maybe it's fine. Maybe it's fine. Howdy, everybody. Hope everybody's having a good day. Hope everybody's weekend was filled with joy and all of that lovely stuff. It looks like we have our first guest coming in quite quick. Let me just finish setting up and then I'll bring you up. Oh, sorry, the vial. Just gotta finish a few things. Gotta write down some things and we should be good to go. Let's bring up Asar the vial.
Here we go.
Asar the vial, how's it going?
Oh, what's going on, bro?
Not a whole lot. Asar, what shape do you think the Earth is?
What shape do I think the Earth is? I think it's round, yeah.
Okay, why'd you join?
I just wanted to ask you about some mathematical physics, if that's okay with you.
Nope, not today. That's for Tuesdays and Wednesdays.
Well, hold on. Watch your mouth, buddy. I'm supposed to be talking to you right now. Okay.
Watch your mouth, buddy. That was a pretty good bit. Well, we got to give him that. Like that. Oops, that I just hit me. That's a good bit, right? Reverb sounding background, space. Okay, yeah, that's. It's probably crisper if it's here, especially if I then turn it down a little bit. So I'll just keep it here, and there'll be a shadow, and it won't be the end of the world. Let's talk to James Robertson. James Robertson, how's it going?
Hello, how you doing?
I'm doing all right. Why are you doing a fake high-pitched voice?
It's not my voice, I'm just house lad. It's my real voice, it's not fake.
I'm sure it is. I'm sure it is.
It's not fake.
All right, let's talk to Frezza. It's not fake. Oh, I can't even do it because I'm still getting over my cold. Frezza, how's it going? Frezza?
Oh my god. Oh, crap.
You Gucci, my Ducci?
Oh my god.
I'll take that as a no. All right, let's bring up Yuji. Yuji. Yuji, how's it going?
Hi,
Yuji, how old are you?
I'm 11. I'm interested in astronomy and physics.
So, Yuji, I encourage you to seek your interests, to dive deep into these things that you care about, but this is an 18+ platform. All right, let's talk to, what was his name? Hey, how's it going?
Hey, man.
I vaguely remember that you were on here fairly recently. What was your name?
My name is Nasser.
Nasser, that's right. And Nasser, you are a flat earther?
No.
Okay, well, today's live stream is about the shape of the Earth. It's about the flat Earth, so I'm going to let you go, but thank you for being here. Reading is indeed hard. Will a real FLERFS please stand up? True. They're too cowardly. Not brave enough to defend their view.
Hello.
AM, how's it going?
I'm good, How are you?
I'm doing all right. AM, what shape do you think the Earth is?
I honestly think it's flat.
All right. Why?
Let me give you my reasons, right?
Please.
I mean, when you look at the science, yes, I understand why you say it's round, but I believe there are some things that we might misunderstand when it comes to science, right? Like when you figure something out, you don't instantly know it. You know, you don't know all of it. But what I'm saying is, like, if you go look, like, you go to the South Pole, for example, and you look at the edges and you look at the pictures we have online, it just doesn't make sense. You know what? I believe they went far deep in, and we haven't really been like, what is it classified to us? You know what I mean?
So why do you
I
think the
believe
Earth is
there's
flat?
more to it. As I told you, I believe some information is being kept from us.
Okay, but why does that make you think the Earth is flat?
Because I think the Earth is a. Let me explain this, right? So, if you tell me the Earth is round, right? Then I tell you, well, we don't know that. But then you go to the only place where you can actually figure it out, right? Like, and when I tell you, okay,
Which is where?
when you're there, show me everything you've got.
Which is the only place that you could actually figure it out?
The South Pole.
You can figure it out wherever you want. You don't have to go to the South Pole to figure out the shape of the Earth.
No, it's different though. It's not the same.
What's different?
How can you say you know what shape the Earth is if you've never been across it?
So, if all you knew, let's imagine that you live on a basketball, right? If all you knew was say the top half, and then like, let's say that there was like, let's say that like around the middle, it was on fire, so you could never cross to the bottom half. You could still figure out it's round just from being on the top half because it curves.
Right. Let's say it is a ball, right? Why is flying over Antarctica at, I don't know, 30, 40,000 feet going to be more dangerous than flying, let's say, for example, I don't know, wherever, you know?
Well, it's
At that height,
really,
I believe
really
it makes no
cold.
difference.
There's nowhere to land, and the winds blow very very quickly.
40,000 feet, I'm pretty sure the difference is minimal.
Well, look, so the atmosphere above, like, and I don't know this off the top of my head, the atmosphere above Antarctica might be very similar to the atmosphere above, like, say, I don't know, Greenland or whatever. But the important point is that Antarctica is an enormous continent, and there's nowhere to land safely if things go poorly.
Well, I agree with that, but
Like, you want to, when you're planning flight paths, you want to plan your flight path so that you're flying over things, or at least flying near things, that you can land at
But the thing is,
if something goes wrong.
No, I understand that. I'm actually an aviation student, but which
So
is
then you would
a
understand.
reason I might think
You
I'm a-
wouldn't want to fly over somewhere
Yes.
that has nowhere to land.
But it's different than Antarctica because it's mostly exploration missions. You know, they go with the plane to check out the landscape, which is
So then
what
what's
I'm
the question? I mean,
getting
if
to,
you're asking why commercial flights don't fly directly over Antarctica, right?
No. Why would a commercial plane ever fly there? It's too far.
Well, that's a
I'm
good
saying-
point. I mean, like some commercial
I'm
flights
saying
do fly quite close, but
planes- let me give you this for example. When I was doing my PPL, I did like a world tour, right? So I tried to go to Antarctica, but I was told I'm banned from flying there. Now I
who?
understand that it can be
By who?
dangerous when you're flying a Cessna.
who told you that you were banned
the
from flying there?
authorities,
What
the
authorities?
The Argentinian Coast Guard, which I don't know
Oh, okay.
why they have to get involved with the aviation things, but
So I
whatever.
mean, like, look, if you are subject to Argentina's, you know, law, then they can do whatever they want. I don't know why Argentina is going to tell you, somebody who's just doing your practice flight or something, why you can't fly there. But that's a question for Argentina. That's not a question about the shape of the Earth.
Listen, I'm sorry, this will be very weird, but I will give you my last point because I have to go, right? But
I'm sure.
I'm saying maybe the Earth is not flat. I'm not a determined flat earther, right? But I believe in knowing everything before I make a conclusion, because I do believe in, you know, space missions. I don't think that's fake. I just don't think.
Well, if you think
everything we
space
see
is real, then the Earth can't really be flat, can it?
Why not?
Because where is space if the Earth is flat?
Well,
Okay, buddy. I'm pretty sure he was trolling. All right, let's bring on Haiku. Haiku, how's it going?
What's up, my friend? How you doing?
I'm doing all right. Haiku, what shape do you think the Earth is?
I think it's round, but I would like to hear your stipulation on why it is round. Like, what is your justification for that?
Yeah, we have pictures and videos.
All right, and who made the pictures and videos?
A guy named Dirk or Kip Dargadas.
All right, and were they convincing to you?
Yep.
And so
But
these.
since you think that the Earth is not round or not flat, I'm gonna let you go. Thanks for being here. Let's talk to Jack Cooper. Oh, let's talk to Dr. Boskovanovich. Dr. Boskovanovich.
Hello.
Boskanovich, or I guess is probably the correct pronunciation. Dr. Boskanovich, what shape do you think the Earth was?
I think the Earth is a torus.
Okay, why do you think so?
Well, specifically a fourth dimensional torus, though.
Okay, why do you think
we
so?
Well, I think a torus makes more sense because, you know, it matches the curvature of like the curvature on the fourth dimensional torus is where we get our gravity from.
So what's the topology of this torus? Are we talking like S1 cross S1 cross S1 cross S1? Are we talking S2 cross S2, or what are we doing?
Yeah.
Those are two separate things. What do you think a torus is?
It's like a donut.
Okay, so so a donut is two-dimensional. What do you think a four-dimensional torus is?
Fourth dimensional. Did I say fourth dimensional?
Mm-hmm.
I guess I meant a three-dimensional torus then. I shouldn't have said fourth dimensional.
Okay, so you think that we live on the inside of a donut? Maybe you think we live on the outside of a donut? You could have just said donut.
I should have said donut, but I thought that would sound
Then I
like
would have known that you're a
trolling.
troll more quickly.
Well, then it would have sounded like I was trolling if I said that. But it makes sense, though, does it not?
No, not at all.
I mean, it makes more sense than the flat Earth things, for sure.
Okay, but the question is not comparing flat Earth versus donut. The question is comparing donut versus globe.
Okay, so you were saying something about the fourth dimensional thing, because it seemed like you were taking that one a bit more serious.
I'm gonna let you go, Dr. Boskanovich, whatever your name is. Let's talk to I am the I am.
Hi.
I am the I am. How's it going?
Oh, it's going good. It's you?
Glad to hear it. I am the I am. What shape do you think the Earth is?
I am indecisive.
You're indecisive.
Yes.
That's an interesting take. Why are you? What makes you so unsure?
Because I'm religious, and the Bible, the ancient laws and rules, like the ancient civilizations, were very advanced in mathematics and astronomy and stuff like that.
Were they?
Yes, they were.
How advanced were they?
They have the world has flat.
So how advanced do you think they were in like mathematics, say?
I mean, they were very advanced because remember the Greek studied in Egypt. That's
So
where the Greek.
What do you think? So do you think that the do you happen to know what the name is for the ratio between the circumference of a circle and its diameter?
Yes.
What's it called?
Pi.
Right. Okay. What did the Egyptians think pi was?
So the Egyptian, so with regards to pi,
Mm-hmm.
Well, I think they were trying to make a perfect circle.
So what do you think? What do you think the Egyptians thought pi was if they were so advanced in mathematics?
They thought it was a constant.
What was the number that they thought it was?
Okay, so they were approximating it. They would just have to use the approximation, but they were very precise anyway.
So they thought pi was 3.1605.
Yeah, but
is pi
they were
3.1605?
No, but that is very good given to their time. isn't
Okay,
it?
so they were less advanced with regards to pi than we are.
I mean, they were the one that. I mean, geometry is the foundation of mathematics. You know.
Sure. What does that have to do with the question about how advanced they were with regards to mathematics? I can agree that a lot of what they did was foundational to mathematics. That doesn't make them advanced. It just makes them foundational. Like addition is foundational to mathematics. That doesn't make addition advanced mathematics.
Yes, well, I'm sure there's a lot of equations in the pyramid, on the walls of the pyramid, mathematical equations.
Why are you sure of that?
It's fact, because this is what most of these scholars used to do in the 1700s. They tried to decipher the scrolls that they found in the pyramid, and that's how they discovered these new laws.
Wait a minute, can you give me examples of these equations on the walls of the pyramid? I've never heard of this. This would be groundbreaking.
Well, I'm sure they are.
Can you tell me about these? What would be an example?
The equation for liquid light.
The equation for liquid light. What pyramid is that in? I've never heard of this. This is crazy.
Yeah.
Let's do some Googling. You can help me find this. I want to learn about this. This sounds fascinating.
Okay. Let's look at.
So I'm gonna Google Egyptian equation for liquid light pyramids. It's a normal thing to Google, right? So which of these links looks good to you? Should I use Facebook? How about Brown? Brown University? That seems good.
Wikipedia. Okay.
There's no Wikipedia link.
Okay. I mean, let's try the one that seems better for you.
So like I mean Brown University is pretty good.
Okay.
The Egyptian triumph, the volume of so this seems to be talking about the volume of a pyramid. It doesn't really seem to be saying anything about light. Just to double check, I'll do a Control F for light. It's not on the page anywhere, so it must be a different website. So what about this one? Phi Pi and the Great Pyramid of Egypt at Giza. That seems promising. Why don't we do a Control F for light here? Okay, so I see in the comments there are some statements about light, but I don't see any. It doesn't look like it's in the article. Okay, so let's try something else. What about unraveling the mathematical genius of ancient Egyptian pyramids? This seems super promising, right? We'll do a Control F for light. The only time it appears is in the word highlight. Okay, so that doesn't seem right. So you say that there's equations for liquid light on the walls of the pyramids, but I can't find it anywhere. What gives?
Well, it's not a certainty, but I'm sure that they are very advanced.
So why'd you say it if you thought that if it's like not true?
You know what? I know they were extremely advanced.
So did you just like make it up?
Kinda.
Why would you do that?
Because we know that they're great and they're advanced mathematicians, right? And they were polymaths.
Why would you make up something just to be proven wrong?
Because you know that they are advanced. They are the most advanced ever.
Look, here's the issue. By making something up and then being immediately proven wrong, it actually completely discredits the claim that you're making. So now I actually think the Egyptians are less advanced than I thought before.
Well,
So
you can't.
making something up seems to be
can't make
counterproductive
that
for your goal.
Mm. Yeah, but anyway, have you ever seen this the Southern Star?
The Southern Star? There isn't one Southern Star. There is a Southern constellation. It's called Sigma, or no, I'm sorry. There is a Southern Star. It's called Sigma Octantis, but it's not very easily visible with the human eye. So no, I haven't seen it. I have been in the Southern Hemisphere though.
Okay, so you haven't been in the Southern Hemisphere?
I have been. I've been to. I have been. Yes.
And where? Chile?
No, I was in New Zealand.
Okay, well, you should have gone to visit the South Pole. And
I was there for work. I wasn't like visiting the South Pole. It's not just something you just pick up and do on a weekend trip, right? Actually, have you been to the Southern Hemisphere before?
No, and that's and
so
that's
it's
what
it's the stars are fascinating because the constellations that you're used to seeing in the Northern Hemisphere, you just can't see down there. It's very weird. Like you know the Big Dipper.
Yes.
So
the also major.
Yeah. So the Big Dipper, if I'm correct, depending on where you are, it's visible most of the year from most places that have large populations in the Northern Hemisphere. So, most times of the year you can see it. If you're, north of, say, the tropics, you'll be able to see at least part of it. And you'll be able to see the North Star wherever you are in the Northern Hemisphere. But the weird thing is, you can't see the North Star at all in the Southern Hemisphere. Why might that be?
That's the thing. A lot of people go to the Northern Hemisphere and they see the North Star.
Mm-hmm.
And so many people go to the North Pole. They go there like it's a tourist attraction.
The North Pole isn't a tourist attraction. There's nowhere. You can't go to the North Pole.
But more people go to the North Pole than the South Pole.
You can't go to the North Pole. There's no land there.
Yeah, and it's just one big snow, but you got like...
No, there's no land there. It's just water.
What, the North Pole?
Yeah, there's no land.
So all the ice caps melted.
No, I mean like they're icebergs floating on water. You can't go to the North Pole. It's like it's not. You can't like walk around on it. I mean, maybe you can if there's like a big iceberg or something. But like these are floating in the water. This is not a tourist destination. There's no pole in the ground that you can go visit.
I know. I didn't really think that there's a pole there, innit?
Well, there's a pole in the ground at the South Pole.
It's the same thing for the South Pole. It's like
no, there is a pole in the ground in the South Pole because there is ground there.
But why is it banned? Is it that a lot of people banned to go there? There must be.
Nobody's banned. You're not banned to go there. Let me show you something. Oops. Just want to make sure that this is what I think it is. There's a ceremonial version and then there's the real version. So there's the geographic South Pole, and then there's there's like a magnetic South Pole, and then there's the geomagnetic pole, and so there's also a ceremonial South Pole which has a literal pole there. The ceremonial South Pole is located near the geographic South Pole, but that pole moves about 10 meters per year because the glaciers move, and so they have something like this pole in the ground is quite close to the actual geographic South Pole. It just moves around because of the glaciers, but you can just go there. I mean, it's not cheap and it's not easy, but like you can do it. Nobody's gonna stop you.
Well, yeah, maybe I would have to go and have a look myself, definitely.
But to be clear, you don't actually have to go to the South Pole in order to know that the Earth is a globe.
Earlier when the guy came on and he asked you, and you said you saw pictures and videos and stuff like that.
Yep.
I thought that you would have come up with some advanced mathematical proof, some geometric proof.
I mean, I could, but why would he understand that? Everybody understands videos.
Okay. No, but video wasn't strong enough, you know what I mean? Like, you got to...
If videos aren't strong enough, then complex mathematics that people aren't trained to understand certainly won't be strong enough.
Okay, I get it. Anyway, it was pleasant to talk to you.
Fair enough. Take care, I am the I am.
Cheers now. Bye.
All right, let's bring up Khalil.
Hello.
Khalil, how's it going?
It's good. How about you?
I'm doing all right. Khalil, what shape do you think the Earth is?
So I think it is a sphere, but I have an issue with how you stand on the Earth. So I don't believe we have the full explanation, you know, because
For it being a
of
sphere?
course
What full explanation is required to be a sphere?
for like staying, like walking normally is okay, but if you fall back, you know, with enough force, then you should be able to go outside of the Earth, you know, but this doesn't happen.
What? If you fall back?
For example, if I am in a mountain, you know, and I throw myself, then I'm too high, I should go out of the Earth, you know.
Yeah, you could. You would just have to go like Mach 35.
Yeah, but you know, if I'm not on the land, so attached to the land, you know, then I should get outside immediately, of course.
What do you mean outside?
Outside of the Earth.
The Earth is like a big ball of rock. If you're not, if you jump in the air, you're no longer on the big ball of rock. You're around the big ball of rock. You'll just fall down quite quickly.
Yes. So if I'm in the air, then I am out of the Earth, you know.
Yeah, and Earth's gravity will pull you back.
Yes, but gravity if I'm attached to the Earth. But one time that I'm high
gravity
enough,
extends off the Earth, not just the Earth, the physical Earth itself.
Then, but how can it keep you if there is nothing you are near or attached to?
You are near the Earth.
No.
Even if you're not on the Earth, you're still near the Earth.
No, because if I am in the mountain, you know, it's far more sky than Earth, of course.
I can't. All right, let's talk to Red Gunner. Red Gunner, how's it going?
How you doing?
I'm doing all right. Red Gunner, what shape do you think the Earth is?
I think it's round, but let me say this before you take me out. If they ever pivot to like the Orion space capsule or something like that, if they mention like how they didn't burn up while falling down.
I'm familiar with the arguments.
Huh?
I'm familiar with the arguments.
Oh, yeah.
Well, it looks like we don't have any good faith interlocutors in the guest box right now. So I think that we will give it a few minutes, and if we can't find any good faith interlocutors, then we'll just have to move on to a different topic. So you guys are being so very generous. Let's read some super chats. From Scrimba1 with the $5. These people have to be AI. There's no way people are this stupid. Oh, you would think, but you would be mistaken. From Christopher Sanford with the £5, making stuff up to be immediately discredited. What is he, a linguistics PhD from Harvard? Oh, that was rough, wasn't it? That was real rough for Captain Skeleton. In fact, I think Captain Skeleton Man might still be live streaming. I just want to check.
Think needs love. I hope
He
needs
is still
love, but not from you especially.
Oh my god, that's so rough. It's fine. It's fine. He's still live streaming. No big deal. And then from Jasper with the €1. Thank you so much, Jasper. I appreciate it. All right, Leroy is in the guest box. Let's bring up Leroy.
Hello?
Leroy, how's it going?
Is it okay if I ask a question, but I believe the Earth is round?
Sure, go ahead.
What do I say to someone who says that they can't see the curves, so they believe it's flat?
Tell them that they can't see the wind either.
Yeah.
Doesn't make wind
Okay.
not real.
Sorry for wasting your time. Thank you.
You're good. You're good. All right, let's bring up Wint. Winty. Winty, how's it going?
Yeah, I'm doing all right. How are
Wint,
you?
what shape do you think the Earth is?
It's a flat, almost like a pancake. Is
Okay,
the way
why
I
do you
can
think so?
describe it. Okay, I have undeniable evidence. Empirical evidence would be standing on the the Burj Khalifa in Dubai.
Sure.
If you stand on the top of the very highest level, I myself have observed it, and many others. You could see New York City, New York.
Really? You can see New York City from the top of the Burj Khalifa. That's crazy.
Yes, and if you go on Google Images, and you'll see it too. Just
okay.
like top it up.
Yeah, let's do that. Let's do that. I mean, I know that this is trouble. Let's do it anyway.
No.
Let's go to map. Oh wait, you mean Google Images? Okay. Seeing. I'm just gonna open up the browser for you so you guys can see what I'm seeing. Seeing New York from Burj Khalifa. Let's see. Well, first of all, the AI overview just says you cannot see New York from Burj Khalifa, of New York City from the Burj Khalifa. But let's just go to the Google Images. So, which one of these is this? Are you referring to here?
Yeah, look, this one. No. Go down a little bit. Yes, this one. Yes, this one. No. Yes, this one. Yes.
Pretty sure that's a. Pretty sure
what
that's
do you
just
see?
that's just like Dubai.
No, this looks like New York to me.
You think that this is New York? You think that New York is surrounded by desert?
This may be Las Vegas over there. I'm not sure.
Oh, okay.
Yeah. So is this like a convincing argument?
Yep. You got me. I'm a flat earther now.
Oh, okay. No worries. I'm happy. Thank you very much.
Man, they're just sending their worst today. Oh. Oh, I'm muted. Do you guys want me to bring on a bad faith interlocutor? I can, if you guys want. Yes? Okay. Let's see how long Angel of Lights lasts. Angel! Long time no being sad because I talked to you.
Yeah, I'm just getting my computer ready to show you evidence. I didn't think you were going to bring me up, so.
Yeah, so Angel, have you heard of the muon time dilation experiment?
How does it prove a globe?
Oh, well, I mean, we're just talking about special relativity, because you don't think special relativity is true, right?
And how does special relativity prove a globe?
Oh, I'm sorry. Are we just going to deflect?
How does it prove a globe?
Oh, well, I mean, it certainly proves that there's no ether, right?
And who disproved the ether?
Yeah, I mean, I was just talking to you about it. The muon time dilation experiment disproves the ether because it proves special relativity.
Okay, how does it prove? How does it disprove the ether?
Because it proves special relativity.
Show me. I can show you Einstein. Do you know that Einstein said in 1920?
Cool deflection. Why don't we talk about the muon time dilation experiment? You want to talk about that, or do you just want to deflect?
I can show you Einstein in 1920 saying.
I'm sure you can. Now, do you want to deflect, or do you want to talk about the muon time dilation experiment?
I'm not deflecting. I'm directly rebutting what you're saying.
Rebutting what? I'm talking about an experiment. You're trying to deflect to some quote by Albert Einstein, which seems like all you have.
Actually, a video of him saying the.
Okay, cool. So this experiment happened. I believe in fact, I believe it happened after he died. So I don't really care what Einstein said.
Cool. And how does this prove a globe? Let's say it's real. How does it prove a globe?
It proves that we don't live in an ether, right?
And how does that prove a globe?
And once you get away from an ether, you can't really account for the downward acceleration of the that we experience on the Earth.
And how does that prove a globe?
And once you can't account for the downward acceleration that we experience on the Earth, the only thing left to appeal to is gravity. And once you have gravity, then you end up with the globe.
And
so,
how does gravity prove a globe? And how does
yeah, because as a result of mass attracting mass in a spherically symmetric manner, you end up with a spherical mass if you have a sufficiently large amount of that mass. Now,
So
do you
you're
want to talk
saying-
about the muon time dilation experiment?
Hang on, so you're saying that gravity, the more mass something has, the more it coalesces into ball, correct?
Yeah, and that's a reasonable
okay.
conclusion.
Yeah. So what has more mass, the Milky Way galaxy or the moon?
Oh, the moon does. Sorry, wait, the moon? No, the Milky Way galaxy does, of course. Now,
why is the Milky Way galaxy a flat disk?
It's a flat disk because it's spinning so quickly.
Oh, so
has angular momentum, yeah. So if you have something with sufficient angular momentum, that is so the issue is that the Milky Way galaxy is not a solid object, right? It's not a single celestial body. Single celestial bodies form roughly spherical shapes as a result of the hydrodynamics involved and as a result of the gravity. There is no way to have a roughly spherical, and by the way, actually, if you want to look at the halo, the dark matter halo around the Milky Way, it's spherically shaped, just so you know. Now, so are you granting that special relativity is true?
No, so something with large mass is now flat.
Well, so to be clear, the total mass of the Milky Way takes on a spherical shape. You know that, right?
The entire universe is flat, Blitz.
No, it's not.
Yes, it is.
It's not two-dimensional.
Is it flat? Is it spatially flat? Yes or no?
It has zero spatial curvature, but that doesn't mean that it's flat.
So flat then.
No, I mean, like it's flat in like a Riemannian sense, but it's not flat in like a pancake sense, which is what you believe.
Is the universe spatially flat, Blitz?
Sure, in the sense that its Riemannian curvature is close to zero. Now, is the universe pancake shaped like you think the Earth is? Of course not.
Oh, so flat then. So the universe is spatially flat.
Can you define for me what the Riemannian curvature is?
What is that?
So then how can you say that that means it's flat? Look, the Riemannian curvature of the universe is close to zero on average. Oh, so surely you know that the Riemannian curvature, you know what that means, right?
What does it mean?
Well, then if you don't know what it means, how can you say that it means that it's flat?
You just said its curvature is essentially zero.
The Riemannian curvature is close to zero. Yeah.
So flat then.
Do you think that if curvature is close to zero, it means it's flat? Do you think that a line is flat?
Yes. If I draw a straight line.
That's not what flat means.
If I draw Blitz, if I draw a straight line, is it curving or straight or then flat?
I don't think that lines have the property of being flat or of being flat, right? Like it's just not like a property of lines. Now, look, the important point here is that you think that the Earth is a pancake, which is not what the universe is. The universe has curved spacetime.
That's a straw man. So on the screen here, right?
It's a straw man. It's not a straw man. What shape? I'm sorry. What shape do you think that the Earth is?
Did I ever say that the Earth was a pancake?
I'm sorry. What shape do you think that the surface of the Earth is?
It's a level topographical plane.
Okay. What shape? I'm sorry. What everyday object would that be similar to?
Is that a shape, Blitz? Is a level topographical plane
it's a geometric characterization, which, you know, in common parlance we would call a shape. So what common everyday item also has a topographical planar configuration?
The Earth.
I'm talking about an everyday object that we experience in our, on a small. How about on a small scale? What everyday object has that? Tell me. On a small scale, what everyday object has that? Like an object that you can hold in your hands.
A coin, a pizza.
Yeah, there you go. You think that the Earth is shaped like a pizza?
No, it's a description of a surface, Blitz. Do I need to teach you
Yeah, it
shape?
is a description of a surface. We use the word shape colloquially to mean descriptions of the geometry of a thing.
So Blitz, is the Earth curved at 8 inches per mile squared?
No.
No.
It's not a description of curvature. We don't describe curvature as inches per mile squared. That's not a way that you describe curvature. You describe curvature in you can describe curvature in terms of inverse radius.
Hang on. So do all the Earth curve calculators use 8 inches per mile squared? Are they wrong?
No, they don't.
Yes, they do.
Anyway, so to be clear, did you grant that special relativity is true?
Why are you pivoting?
I'm not pivoting. You just have gotten me off topic, and now I'm bringing you back to topic.
Wait. So hang on a second. Are you saying that the Earth doesn't curve at 8 inches per mile squared?
I'm saying that that's not how we talk about the curvature of the Earth. Now, are you saying that special relativity is true?
What is the curvature rate of the Earth?
I'm sorry, is special relativity true?
It doesn't prove the shape of the Earth. Couldn't care less.
Oh, okay. So you would agree that it's possible that special relativity is true?
I couldn't care less. It doesn't prove the shape of the Earth.
Would you agree that it's possible that special relativity is true? Would you agree that it's possible that special relativity is true? Answer the question, scumbag.
It doesn't prove the shape of the Earth, but
that's cool. I'm just asking you a perhaps unrelated question.
So you think that a fourth dimension can bend and warp, Blitz?
I'm sorry. It seems like you're avoiding the question. Do you think that special relativity could be true?
If it's real, does the fourth dimension
special relativity has nothing to do with the curvature of space-time?
Special relativity has nothing to do with the curvature of space-time.
Now, do you think that special relativity could be true?
And okay, I'll grant it to you. Has it proved a globe?
I'm sorry. Why are you dodging the question?
I'm granting it to you, Blitz.
Wait. So you agree that it's possible that special relativity is true?
Okay, and how does it prove globe?
Wait, no. I'm asking you. Do you agree that it's possible that special relativity is true? I'm not asking you to grant it. I'm asking if you agree that it's possible that it's true.
No. Okay, yes. How does it prove a globe?
Clipped and shipped. I'm glad that we agree that special relativity is possible. It's possibly true.
How does that prove
yeah, so then we get to, so once we have special relativity is true, we no longer have an ether, which means that we have no way to account for things like the Coriolis effect or the gravitational force downwards, correct?
And how does that prove a globe?
So once you no longer have a way to account for the Coriolis effect, for the gravitational force downward, once you can't account for these, you need to look for some additional accounting, and it turns out the additional accountings are very, very indicative of a spherical body.
And how does that prove a globe?
Yeah, so for example, for example, if you are living on a planar surface, is that what you call it, a topographical plane or something like that? If you're living on that, then you can't have a Coriolis effect from rotation. However, a globe can have a Coriolis effect from rotation. Similarly, there's no Coriolis effect at all. It's not a real thing. It's made up.
So the apparent deflection of an object in a rotating system, are you claiming the Earth has that?
Yeah.
Oh, really? Okay. Let me show you something then.
So wait, hold on. Do you reject the Coriolis effect? You just think it's like not real at all? You don't think that there's any correction that has to be done for any sort of trajectories on the surface of the Earth? You don't think that that's the case?
The Earth does not have Coriolis. So on screen, right?
Okay, so I've spoken with an artillery expert, and they use Coriolis corrections in order to make trajectories for their artillery matching. Do we agree on that?
And I spoke to an artillery expert who didn't know what Coriolis was.
Okay, so just to be clear, do you think that like artillery manuals don't include Coriolis corrections?
Okay, so are you saying that the Earth rotates?
Why are you answering my question with a question?
I'm asking you. Are you saying, to clarify your evidence, are you saying that an artillery shell is affected by the Earth rotating under it?
Sure, the Coriolis effect could be relevant for the Coriolis effect.
Okay. Yep. If I throw a ball on the Earth to you, Blitz, does the Earth rotate under that too?
Look, so the Coriolis effect is colloquially understood as the Earth rotating underneath something, but it's a little bit more complicated than that, especially when you're not directly above the pole.
On screen here, Blitz, this is Coriolis effect, correct? Can we both agree
that's an example? That would be an example of the Coriolis effect. Yeah.
Thank you. So
now just to be clear, do you think that artillery manuals don't take into account any sort of Coriolis effect? Do you think that that's the case?
I'll grant it to you in your book. No worries.
Okay, so to be clear, artillery manuals, they will take this into account then, is what it sounds like what you're telling me.
Okay, great. I'll grant it to you. Watch this.
Okay, so wait a minute. Why does this have to be taken into account? That's so strange.
Okay, can I answer that now?
Yeah, please explain.
If the Earth rotates under an artillery shell, and you just agreed that what I have on screen here is Coriolis. If I throw a ball to you, Blitz, does the Earth rotate under it?
I mean, look, the Earth rotating under it is a colloquial way of describing what actually happens for the Coriolis effect. It's a little bit more complicated than that when you're not directly over the axis of rotation.
All right.
But yes, there is a small, probably negligible Coriolis effect that the ball would experience if you throw it to me, if we're just standing next to each other. Absolutely.
Can I see the evidence for that?
Look, I'm making the claim that it's probably sufficiently small that you probably couldn't measure it. My point is that we can measure it for things that move very, very quickly over large distances, like artillery shells.
Okay, like a sniper bullet.
No, like artillery shells. I don't know about sniper bullets. I don't know a lot about that.
Does the sniper have to take into account?
I don't know. I've never spoken with a sniper. What I have spoken with is an artillery guy.
Okay, so an artillery shell is affected by Coriolis. Is everything that's in the air for long enough affected by Coriolis?
Not if it's not moving quickly.
Oh, really? So wait. So if
The
I hover a
Coriolis
helicopter,
effect. The Coriolis effect depends on the speed.
if I hover a helicopter for 51 hours, does
Depends
the
on the
Earth rotate
speed
under
over
it?
the surface of the Earth. Importantly.
I'm asking you, if the Earth rotates under an artillery shell, if I hover a helicopter
That's not
for
the
51...
Coriolis effect. Is not the Earth rotating underneath a thing. That is a colloquial way of describing it. I don't know why you have this this like intrinsic desire to try to strawman the position to try to make your point. It doesn't look good on your end when I've told you now 3 times that the Coriolis effect is not just the Earth rotating underneath something. Rather, the Coriolis effect is a fairly complicated phenomenon that if you are near the pole or the axis of rotation, then yes, you can describe it as the thing rotating underneath you. But if you are not near the axis of rotation, the Earth rotating underneath you is not the best way to explain what's going on.
Okay,
Because the Coriolis effect depends on the velocity of the thing moving, not just on the rotation of the Earth. Do you understand the difference?
Just to confirm, is this recreation of Coriolis on screen that I'm showing?
Yeah, sure. And notice there that they're throwing a thing across the axis of rotation.
Right. Yes. Okay.
Notice
now
how
watch
they're
this.
near
If
the
we
axis of
hover-
rotation there?
Thank you. So if we hover a
Yeah,
drone
yeah,
above
okay.
this
I'm glad that we agree.
If we hover a drone above this spinning merry-go-round, does the merry-go-round spin under the drone?
If you hover a drone above the spinning yeah, sure, the merry-go-round will spin under the drone.
Okay. If we hover a helicopter on the Earth, does the Earth rotate under it?
If you were at the North Pole, sure. It would take a while, but yeah, sure.
If the helicopter's at the North Pole, the Earth rotates under it.
Yeah, of course.
Oh, show me the evidence. Show me the evidence for that.
Well, look, I mean, you're asking me a hypothetical. I don't think that a helicopter has ever been at the North Pole. But what we do know is that the Coriolis effect is a measurable effect. Do you think that it doesn't? Do you think that the Coriolis effect is not measurable?
Wait, Blitz, he's saying it rotates under at the North Pole.
Wait, Angel, do you think that the Coriolis effect is not measurable?
Yeah, it's not.
Okay, you don't think that there's any phenomenon that where you could measure the Coriolis effect, like in artillery or anything like that? You don't think so?
So you just said that it's measurable on a helicopter, correct?
I didn't. I said that would happen. I didn't say that it did happen.
It would happen. Okay.
Yeah.
So the Earth rotates under a helicopter, Blitz.
Yeah, that
You
would
wanna lock
happen.
that in? Show me the evidence for
that would happen if you're at the North Pole, sure.
Show me the evidence for that.
I'm not saying that it's ever happened. I'm saying it would happen.
Wait. So it would happen. So if I'm at the Tropic of Cancer.
Yeah, this is a prediction that I'm making. Yeah. So now, do we agree? Do we agree that the Coriolis effect is a real measurable effect that you can see on artillery, for example?
Blitz, you just said the Earth rotates under a helicopter. If we're at the Tropic of Cancer, does the Earth rotate under the helicopter?
It's not that simple, no. Here, let me show you this. This is fun. So why is it that in this ballistics table for artillery, you have to take into account the rotation of the Earth? What's going on here?
Oh, okay. Oh, really? So what was the deflection? How far did it go?
This depends on the bearing, on your latitude. This depends on your range. See how it depends on your range?
How long was the projectile in the air, Blitz?
This depends on the range. See that range there?
Your evidence. How long was the projectile in the air?
Do you mean how many seconds? That just depends on how fast it's going.
So if it's in the air for a couple seconds, the Earth will rotate under it?
If it's in, sure. If it's going thousands of miles an hour, sure, there will be a relevant effect.
Cool.
You realize the Coriolis effect depends on the speed, right?
Okay, you just said thousands of miles. Great.
Thousands of miles per hour, yeah.
Thank you. If we fly a SR-71 Blackbird max speed north to south, and they come in to land at an airport north to south, do they have to take into account Coriolis, or do they treat the runway stationary?
So when they're landing, of course they don't have to take into account. They're just trying to aim. They're just trying to aim their plane. They're not. They're also, by the way, they're also not landing at thousands of miles per hour.
No, but I'm saying if they were to fly over the equator, would the Earth be rotating under that plane 1,000 miles an hour?
The Earth's saying the Earth rotating underneath something is a way of accounting for the Coriolis effect is a misunderstanding of what the Coriolis effect is.
Oh, so wait, how come you said that it was affected by the artillery shell? How did the Earth rotate under that?
I didn't say that. I didn't say that the Earth rotated underneath the artillery shell. I said the Coriolis effect was relevant for the artillery shell.
How is Coriolis relevant if the Earth didn't rotate?
Because it has to be taken into account when actually making these artillery calculations.
Really?
That's how it's relevant.
So it got taken into account, so when they shot, the Earth deviated, correct?
when they shoot as a result of the Earth's rotation, they have to make an or before they shoot, I suppose you wouldn't make the adjustment after they shoot. Before they shoot, they have to make an adjustment for the angle that they're firing in to account for the fact that the Coriolis effect affects these kinds of high-speed, long-distance trajectories. Does that make sense? By the way, I'm giving you like so much charity and you're being like insufferably uncharitable, so do you want to like try calming it down? Sorry, actually, one sec, I have a phone call.
I'm being uncharitable, dude. Guys, he said the Earth rotates under things.
Sorry, that was the endodontist. I just had to take the call.
Okay. All right, cool. So if you agree that merry-go-round is a replication of Coriolis
it's an example of the Coriolis effect. It's not a replication of everything that happens on the Earth.
Thank you. So does the atmosphere move with the Earth tangentially, or does it not?
In part, yeah.
Oh, so no Coriolis, no drift.
The Coriolis effect, look, so the Coriolis effect depends on the speed over the surface of the Earth. You understand that? So, or no?
So the Earth rotates at the equator 1,037 miles an hour east, correct?
Do you know how to answer questions, or are you just going to continually strawman me?
Well, you don't claim the Earth rotates 1,037 miles an hour at the equator?
Why didn't you answer my question? Why did you answer my question with a question?
I did answer it.
No, you didn't.
Yes, I did.
Okay, repeat back to me what my question was.
Are you okay, Blitz?
Repeat back to me what my question was, please.
You said that the Earth has Coriolis, okay? It has a tangent, and you said
no, that wasn't my question. My question was, actually, we can just play it back. Do you want to just play it back? Let's just play it back. One sec, I'm pulling up the playback. This is right after the phone call, I believe. So application of the Coriolis effect. Look, so the Coriolis effect depends on the speed over the surface of the Earth. You understand that? Or no?
So the Earth rotates
on the speed over
no drift.
Let's play it back one more time. Coriolis effect.
Okay, no, I gotcha. So you're saying it's affected by the speed of the thing over the Earth, correct?
The Coriolis effect.
Okay.
And do you notice that you didn't actually answer my question? You just asked another question in response.
Okay, so you're saying that it depends on the speed of the object across the Earth, correct?
Over the surface of the Earth, yeah.
Okay, thank you. So according to your globe, your Earth is rotating 1,037 miles an hour east of the equator, correct?
Relative to what?
Relative to the North Pole or the center of the Earth.
Sure.
Okay, if we fly an SR-71 Blackbird across the equator, 2,000 miles an hour.
Do you mean going north-south or east-west?
Let's say we're going north-south.
Okay, there's no Coriolis effect if you're going north-south across the equator.
North-south.
Yeah, because the velocity vector is in the same direction as the rotational angular velocity vector, and so the cross product is 0.
So no Coriolis, no drift.
There's no Coriolis effect when going north-south. There would be a Coriolis effect when going east-west, for example.
Oh, really? Okay. So your Earth is...
Yeah. I mean, like the Coriolis effect is pretty well understood. It's just the angular velocity vector crossed with the velocity vector. This is a pretty well understood phenomenon. You can take a cross product if the axis of rotation is this direction and say east is this direction. So then your cross product, so again, north, east. So then you would end up going in.
Okay, so if we get a plane flying 500 miles an hour...
So the Coriolis effect would be downward, by the way, if you're flying east at the equator.
Okay, east, you're saying it doesn't affect it north-south. The Earth doesn't rotate under it north-south, no Coriolis. If we fly east...
I didn't say that the Earth's not rotating it under north-south. I've been saying that over and over again. This is the fourth time you strawmanned me. So that's neat. By the way, just so everybody knows, you guys understand, this is what I mean by Angels of Light is a bad faith interlocutor. He doesn't actually take into account what I'm saying. He just tries to strawman me repeatedly so that he can make himself look good and make it look like my position is silly, despite me correcting him on what my position actually is.
Blitz, I asked you, if we fly north-south, does the Earth deviate under the airplane flying?
And my answer was that there's no Coriolis effect when you're flying north-south at the equator, because the cross product between the angular velocity vector and the velocity vector of the thing doing the flying is 0 because they're in the same direction.
Right. Okay, so no Coriolis north-south then?
Only at the equator.
Okay, if we're on the Tropic of Cancer flying over it, 2,000 miles, does the Earth rotate under it 15 degrees?
I don't know what you mean by does the Earth rotate under it. There is a Coriolis effect.
So there's an apparent deflection of the Earth relative.
There is a Coriolis effect.
So the plane deviates relative to the Earth then?
There is a Coriolis effect, and that Coriolis effect can be
what else
accounted
are
for
you-
while flying.
Oh, really? Why do they treat the runway stationary then?
Treat what runway? What runway stationary?
When I asked you if they landed on north to south runway on the Earth, how come
Look,
they?
so when you're trying to land, you're just looking at the runway and you're lining up your plane with it. That's all.
Okay, and does it deviate relative to the plane?
Does what deviate relative to the plane? Of
The
course,
runway,
there's going to be
yeah.
all sorts of effects that are going to make you try to keep your plane straight. Do you think that if you just take your hands off the controls and then try to just let the plane go down, that you won't like get off course? Like, of course you will.
Is the runway stationary relative to the plane?
Obviously not.
No. Oh, so now they have to take.
Yeah, because the plane's moving, so the runway won't be stationary relative to it. Obviously.
So the runway drifts.
By the way, this is like a huge blunder on your part, Angels. Like, of course, obviously, the runway will not be stationary relative to the plane. The plane is moving through the air.
How come in the TOD calculation, the runway, they treat it stationary?
Nobody treats the runway as stationary because from your perspective, it's moving backwards at, however fast you're moving. Obviously.
Wait,
Enormous blunder.
The runway moves under the plane, Blitz. Is that what you just said?
From the plane's perspective, yeah, duh. It's called relativity.
Wow. Can I see evidence for that, please?
I'm sorry, do you think that from the plane's perspective, the plane is moving?
The plane is moving, yes.
From the plane's perspective, relative to the plane. Okay,
Right.
what is the velocity of the plane relative to the plane?
If you're in the plane, you're flying with it.
Yeah, so your velocity is 0. What is the velocity of the runway relative to the plane?
0.
The velocity of the runway relative to the plane is 0. So you think that when you are in the and just clarifying here, velocity is the rate of change of position. So you think that from the plane's perspective, the position vector that corresponds to the position of the runway is not changing?
The runway is stationary relative to the plane, yes.
Oh my God, Angels! I didn't know you were this dumb.
You think,
So both the plane and the runway are stationary relative to the plane.
No.
Is that what you're telling me?
Now you're straw running me. When the plane is flying over the Earth 1,000 miles or 2,000 miles across the Earth, okay, and they come into land on a north to south runway, and they're slowing down, they're flying on that runway. Is the runway stationary relative to the plane? Yes or no?
We're talking about the airplane, right?
I'm asking you about the runway. Is the
runway stationary relative to the airplane?
Yes.
Obviously not.
Oh, so it moves under the airplane. They have to chase it.
That's why they have to kill their speed. Otherwise they would already be at rest.
Guys,
this is so embarrassing for you. Oh my God. This is so rough. Wait a minute. So do you think that the position of the runway changes relative to the plane as the plane is approaching for landing?
No, the runway is stationary relative to the plane.
Wait, hold on. Answer my question. Okay, the position of the runway relative to the plane, is that changing?
Of course, if the plane gets closer to it, it's going to change, right?
Yeah, that means that the runway is moving relative to the plane.
Oh my God, wait, so the runway is moving relative to the plane?
Yeah.
So they're not landing on a stationary runway?
When they get to 0 speed, the runway will be stationary. Yeah, that's called being stopped.
Okay,
Until then, the runway is moving relative to them. Yeah. When they touch down, the runway is moving backwards relative to them.
Okay, so is the Earth stationary? Do they treat it stationary? Yes or no?
Do they? Are relative to the plane or relative to what?
Yes, relative to the plane.
Relative to the plane, it's obviously not stationary. This is like middle school physics.
Oh my God! So the Earth rotates under it then.
Relative to the plane, everything is moving except the things that I guess would be flying alongside the plane. Those might not be moving. This is so rough for you.
Does the Earth rotate under the plane?
Oh, you don't even know what relative means. Oh, this is so embarrassing.
He's spazzing out. Does the Earth? Okay, look. Is the runway stationary relative?
This is going straight on YouTube, by the way. This is great content.
Please do. Yeah, I'm recording too. This is hilarious.
Like, just to be clear, you understand that if the runway's position is changing from the plane's perspective, that means that relative to the plane, the runway is moving, right?
So if the runway, the runway is moving.
So the runway is moving relative to the plane. Do we agree on that?
No, the plane is moving relative to the runway.
Do you understand what relative means? So by the way, both those things can be true. The plane can be moving relative to the runway, and the runway can be moving relative to the plane. In fact, not only can both of those things be true, if one of them is true, they both have to be true by definition.
Okay, so if we hover if we're hovering a helicopter,
he wouldn't understand that. That went way over his head.
If we're hovering the helicopter at the runway and we fly a plane to the runway landing on it, is that runway going to deviate 15 degrees per hour?
Is the runway going to deviate 15 degrees per hour? Relative to what?
Relative to the aircraft. Is it going to deviate under it and drift? Yes or no?
Is the plane or is the runway going to deviate under it and drift? Probably not, because the plane is in the air that's also moving quite close to the ground.
So stationary then, so no Coriolis.
No, it's not stationary. The runway is absolutely moving relative to the plane.
Wait, so the Earth is rotating under the plane? Is that your? Is that
I didn't say that. I said that I said that the runway is moving relative to the plane.
Okay, how can the runway be moving if it's attached to the Earth? Is the Earth
because
moving?
The distance, because the position of the runway relative to the plane is changing. This is so basic.
So is the plane approaching a stationary runway?
From the plane's perspective, the runway is approaching a stationary plane.
Oh my God, Blitz! There's no
it's
way
like you don't even understand basic Galilean relativity.
Does the runway drift east?
I have answered your question so many times and you just don't understand it, which is so embarrassing because you try to use these fairly complicated physics topics and you can't even fathom basic Galilean relativity.
A plane treats the Earth stationary, Blitz. Are you
Cool, you can keep repeating your phrase if you want. That doesn't make it true. From the plane's perspective, the runway is moving. From the plane's perspective, other planes are moving. From the plane's perspective, the helicopter that's hovering over the runway is moving.
Is the Earth relative to the
That
plane
is
moving?
that's what Galilean relativity is.
The Earth relative to the plane moving.
Is the Earth yeah.
Oh, so the Earth rotates under the plane.
I didn't say that.
So how is it moving relative to the plane if it's not rotating under it?
It depends on which part of the Earth, right? Because parts behind will be moving at different speeds relative to the plane. Parts to the side will be moving at different speeds relative to the plane. But for example, you could take like a tree that's in the ground to like the side of it, and that tree will be moving backwards relative to the plane.
But if you're standing next to the tree, is the tree moving?
Not relative to you, but relative to the plane, it is.
Okay. Because the plane's moving, right, over the Earth?
Relative to you, the plane is moving, yeah.
So when a plane flies over the Earth...
This is so hard for you. Angels, have you ever considered that this is just like a concept that might be too advanced for your koala brain? Like, is this something that you've considered before?
You're double speaking into oblivion, and it's freaking
Double
hilarious.
speaking? Bro, anybody who has taken even a first week of high school physics would know what I'm talking about. But clearly you don't.
Okay, really? Okay, so you just said that this
Clearly.
is a...
Apparently you don't know what Galilean relativity is.
You just said that this is an effect of Coriolis. This is Coriolis effect being recreated.
Yeah, it's an example of the Coriolis effect. Yeah, sure.
Right, okay.
It's an example, by the way. It's not like a it's not like the definition of it. It's an example.
Yeah. So when a plane flies over the Earth, they treat the runway stationary, Blitz. It's not moving.
When you say
relative to
they
the plane.
treat the runway stationary, what are you talking about? Are you talking about like relative to them?
It's not moving, Blitz.
Not moving relative to what?
It's not really moving relative to the plane.
Oh, it is moving
stationary.
relative to the plane, though. You've already agreed on this.
It's, oh my God. So
Of course it's moving relative to the plane. Unless the plane's not moving. Unless the plane is like sitting on the Earth.
How come? Okay, so the runway's moving relative to the plane.
Yeah.
Oh, really? So they chase it east when they land?
I didn't say that.
Which way is it moving?
Backwards, for the most part. I mean, it depends on like whether or not there's wind and stuff that's buffeting the plane around. It may very well like appear that's moving left and right as well.
But it's actually stationary, right? If you're standing
Relative
at the
to
runway,
what? It's actually stationary relative to what? Do you not understand this?
You're standing on the runway.
Motion is relative.
If you're standing on the runway, are you moving 15 degrees per hour?
If you're standing on the relative to what? Moving 15 degrees per hour relative to what?
Relative to the center of the Earth.
Yeah, sure.
Oh, so if the plane goes and lands on that, it's moving it is moving relative to the center of the Earth. When the plane
runway?
lands, yeah, so it's moving which
relative
way?
to the
East.
center of the Earth, the runway would be moving at 15 degrees per hour. Sure. Sure.
Correct.
Sure.
Yeah. And when the plane goes and lands on it, do they change the runway east, or do they treat it stationary?
Depends on what the plane's motion is relative to the center of the Earth, right?
Oh, wow. You're never going to answer it, are you, Blitz? You're just never
I just
gonna
did.
do
It depends on what the plane's motion is relative to the center of the Earth. I mean, the point is that and I can clarify. Maybe this will help you. So Galilean relativity is transitive, meaning that if you know how A is moving, or if you know how B is moving relative to A, and you know how C is moving relative to B, then you can know how C is moving relative to A. Or put another way, if A is the center of the Earth, B is the runway, and C is the airplane, if you know how B is moving relative to A, and you know how C is moving relative to A, then you can figure out how C is moving relative to B.
Okay. So if I let go of a helium
does that make
balloon-
sense?
So if I let go of a helium balloon, does the Earth rotate under it?
Why didn't you just answer my question? Why did you just start it with another question?
You just made a statement.
No, I asked if that made sense. Now I have a suggestion, a possible way that we can check to see if this is something that's even worth talking about. Just
you brought
one
up
sec.
Coriolis, not me.
One sec.
I want to talk about flat Earth. I want to prove a flat Earth to you.
One sec. So, could you do me a favor and answer this question for me? So the question is, a car is moving down a flat horizontal highway at a constant speed of 21 meters per second, when suddenly a rock dropped from rest straight down from a bridge crashes through the windshield. The rock strikes the windshield at a right angle, and the windshield makes a 60-degree angle with the horizontal. Can you find the speed of the rock relative to the car when it hits the windshield?
No, I don't care about that. How does that prove a globe?
Well, my point is that this is a question about relative velocities, and it seems like if you can't answer this very basic question, which I asked within 3 weeks of teaching a very first course in physics, if you can't answer this question, then I don't think that you're equipped to have conversations about like the Coriolis effect, because that's all about relative motion.
What is the Coriolis effect? Define it.
It's an apparent force as a result of being in a non-inertial reference frame. It's a specific apparent force.
Oh, so is the Earth treated as non-inertial now?
The Earth, standing on the surface of the Earth is being in a non-inertial reference frame, yeah.
Oh, so you're moving 15 degrees per hour. So how come? Okay, great. So
relative to the center of the Earth, yeah. But like the point is I don't think that you have the boots for this hike. Like you can't even answer a basic question about Galilean relativity. So I don't think that this is like something that you're equipped for.
You're not equipped for it. The Earth is treated.
I just asked you like a really basic question.
The Earth is treated
I can go pull up the answer book for you if you want. Yeah, the one that I wrote. Would that help? Maybe this will help. One sec. Let me pull something up.
Yeah, pull it up and tell me how it proves
one moment.
I'm sure it's not a red herring, right, Blitz? It's not a red herring to the shape.
Well, no, I mean, it's just like, it'll be a good time to like teach you. It's like a good teaching moment, right?
Teach me what? Exactly. Teach me
Galilean relativity? Galilean relativity.
Which doesn't prove the globe, right?
Well, I mean, it's pretty instructive. So, like, if you don't understand Galilean relativity, then you just might not have the boots for like the Coriolis hike, right? That's the point.
Does it prove the globe?
Does it prove the globe? Galilean relativity, probably indirectly. You'd have to do some work, but the point is like you've been asking questions that are pretty indicative that you just don't understand what we're talking about. So, which is fine, and I'm happy to teach you. I just want to pull up the actual. Is it this one?
You're not proving the globe to me by doing any of this.
Oh well, at this point, I'm just lecturing, right?
You're lecturing, you're not teaching me the globe. Can you teach me something?
Well, no,
about
I mean that's what the lecture is, right? Why is this
Can you teach me
others?
something about the globe?
Here,
instead of running away and red herring off, it doesn't even prove the globe.
Chill. We'll get there. I just have to find the right thing. Oh, oops.
Yeah, you don't want to talk about the curve.
So it's problem 4. So this is the answer that my TA wrote up when I was teaching this. So this will help.
Yeah, let's red herring off the subject, right, Blitz, and talk about anything but the shape of the Earth when I'm here, right?
I mean, we've already gotten there, but I just realized that you actually have no idea what you're talking about. So I can teach you, and then hopefully you won't make these mistakes again in the future.
We haven't spoken about
so the question was, a car is moving down a flat horizontal highway at a constant speed of 21 meters per second when suddenly a rock dropped from rest straight down from a bridge crashes through the windshield. Sorry, let me make this a little bit smaller so
the car moves into the rock.
Yeah, so the car is moving and then the rock's falling and then they kind of collide together, right?
Does the Earth rotate under the rock?
So the rock strikes the windshield at a right angle, and the windshield makes a 60-degree angle to the horizontal. So the windshield is like up at a 60-degree angle, like it's a 60-degree angle relative to the horizontal, and the rock hits it at a right angle.
And what's your point?
Now the question is, what's the speed of the rock relative to the car when it hits the windshield?
I don't know.
So in the car, no, that's fine. That's fine. We're gonna go over the answer. So in the car's reference frame, the car is moving to the right, but from the car's reference frame, the car is stationary. And but what we know is that relative to the car, the rock hit at a 90-degree angle. So that means that the velocity of the rock is in this direction, whereas the car's motion is in this direction. And we know that that's a 60-degree angle pointing downwards there. So we can use
to what?
it's relative to the horizontal, relative to So what we know is that the speed of the car divided by the speed by the relative velocity. This is the velocity of the rock as it strikes the windshield. The speed of the car is equal to the sine of 60 degrees. Do you understand why it's equal to the sine of 60 degrees?
60 degrees off the horizontal, which is not curving, right?
Do you want? Sure, we can pretend the Earth is flat for this example. Yeah, we can pretend that the Earth is flat for this example. Yeah. So the velocity of the car divided by the velocity of the rock is equal to the sine of 60 degrees.
And what do you mean pretend?
So because we know that because we know how fast the car is moving at 21 meters per second, we can use this equation to solve for the speed of the rock crashing through the windshield relative to the car, which is 14 times the square root of 3. Does that make sense?
Okay. So, and what does that prove? Exactly.
Well, this is hopefully explaining to you how relative motion works. I can actually pull up my lectures on relative motion if that would help.
Okay. Yeah, and how does that prove?
Yeah. Let me pull them up really quick for you.
So off the guys, he just said it's off the horizontal, which is 0 degrees.
Quarter. No, not homework. We want lecture notes.
You just proved a flat Earth.
That's too long.
1.1.
Yep, I definitely proved the flat Earth by teaching you about. No, that's not the right notes. By teaching you about relative motion. Definitely, that's what happened.
Right.
Absolutely, that's what happened. 100%.
Why'd you use a flat baseline in your example?
Oh, you don't have to. You can just choose to if you want.
Can you show me the one that doesn't use that then?
Oh, I don't think that you'd understand. Oh, here's the lecture notes. Here we go.
Oh yeah, cool story. Now show me the one that's spherical.
Hold on. I just got to get to the relative motion part.
Show me the one that's spherical. Use a globe. Why'd you use? Hold
on. We gotta get through Galilean relativity before we can even get to the shape of the Earth. Because you're just not equipped yet, which is okay. It's totally normal.
So you just admitted we're not talking
simple
about
linear or straight. So there's straight line motion. We have instantaneous velocity. Sorry, I'm just scrolling through the notes, so I'm sure that we'll get to the relative motion part eventually. Ball rolling over a hill. That might be a little bit advanced for you, but motion in multiple dimensions. This might involve relative motion. Okay, so this is magnitude. There's circular motion. That might be hard for you, but we could talk about it if you wanted to. Projectile motion. I know that relative motion. Maybe it's lecture 4.
You want to not red herring off the topic, Blitz, or you good?
No. I mean, like you gotta know the topic before we can talk about the actual. You gotta know the underlying science before we can talk about the actual topic, right?
I have to know that the Earth is measured flat in your example to talk about the shape of the Earth.
No, you don't have to know anything about that because this is about instantaneous motion,
Why
right?
did you use a flat Earth then? Why did you?
Well, I said that you could use a flat Earth, but you don't have to. You can use whatever. You can use whatever shape of the Earth that you want.
Why didn't you use a globe then?
You can. We're just talking about tangent vectors, so it's irrelevant.
And then use a globe. This is.
Oh, do I actually not lecture on Galilean relativity at any point? I guess I just assumed that my students kind of intuited that, but maybe I should, because I guess if I have any flat earthers who are my students, then that would be a problem because you guys wouldn't understand Galilean relativity. Yeah, I guess I don't talk about Galilean. Oh no, here it is. There we go. Okay. So let me show you these lecture notes about motion in multiple dimensions. This might help. So it turns out you actually can't specify location with just a number. In fact, the number will tell you how far away something is, but not what direction it's in. And in three dimensions, you need a vector to do the same, a position vector, arguably. We would say it's x units in the I direction, y units in the j direction, and z units in the k direction. Does that make sense?
Wait. So x, y, z coordinates, is that what you just used?
Yeah. These are Cartesian coordinates.
Oh, welcome to flat Earth. You know that's a flat baseline, right?
He doesn't even know. He doesn't know. Now, so see, this displacement vector is the difference between the two Cartesian vectors indicating the position relative to an origin. And so that displacement vector is going to tell you the position vector relative to your initial position.
Blitz, you just proved a flat Earth again. You used x, y.
I proved a flat Earth again.
Yeah, is x and y longitude and latitude, Blitz?
Are x and y I mean, they can be. They're variables. They can be whatever you want them to be.
No, they are.
I'm
That's a
surprised
flat
that I actually don't talk about Galilean motion anywhere. That's really surprising.
I'm surprised you proved a flat Earth again. What is that Z angle coming off, Blitz? What is the Z coming off?
What's the angle?
On my picture here, what is this Z coming off?
Oh, I can't see your picture. It's very small.
Why don't you put me in the big box then?
Because you're on 4 platforms and I can't make you big on all of them.
No. So now you're clinically blind. You can't see my screen. Hey, in the chat, guys, can you see what I've got on screen? Okay, so is the Z coming off XY?
I mean, I'll trust you if you say it does. It's just kind of small.
No. Yes or no. You're the one that was teaching me earlier.
Look, I just can't see the angle that you're pointing at. Like, yeah, I believe you.
Hey, Smarty Pants, does Z come off XY?
Oh, you mean like in standard Cartesian coordinates, is Z coming like perpendicular to XY? Absolutely, yeah.
Oh, so off a flat plane then. Yeah, so here we go.
In Cartesian coordinates, yeah, absolutely. So did you know that coordinate systems don't actually define the shape of the thing that you're on? You can use any coordinate systems that you want. Did you know that?
So an X and Y coordinate is not a 2D plane?
They define a 2D plane. That doesn't mean that the thing you're on is two-dimensional or a plane. So did you know that you can use X and Y coordinates to describe the position, or X, Y, and Z coordinates to describe the position on a sphere? Did you know that?
On a flat plane. So hang on.
Did you know that you can use X, Y, and Z coordinates to describe position on a sphere?
Go ahead, show it.
Okay.
I challenge you to show that.
Yeah, sure. 1 second, let me pull it up.
So do you agree that X and Y is a 2D plane or not?
It depends on how they're embedded into the larger manifold, but
no,
traditionally they are. Traditionally they're taken to be, yeah.
Oh, so a flat Earth then. So you proved a flat Earth again.
No, not a flat Earth. You're confused again. Yeah, okay, so here we go. Let me just show you something. Sorry, that's the wrong notes.
Guys, Google if XY is a 2D
here you go.
plane.
So here we have, here we have the Wikipedia article on spherical coordinate systems, and notice that you can define X, Y, and Z coordinates
show it in
on
a
sphere.
Show it in a depiction.
Oh, you want a picture?
Show me that in an image, please. And you're gonna what you're doing.
Are the equations too sophisticated for you?
No, show me in the depiction.
Do you not understand what the equations mean? Because here's the X, Y, Z coordinates that are defined on a sphere. In fact, they're defined in terms of spherical coordinates. There's a diffeomorphism, except at a point, between the spherical coordinates and Cartesian coordinates. But that might be too sophisticated for you, right?
So is this what you're doing, Blitz?
I have no idea what you're showing me. I can't see it. It's too small.
You don't know an elevation angle?
I can't read what I'm seeing. It's very small. Is that a meme? Does it have meme text below it?
No.
I see like the big white text. Do you think in memes?
I can show you a real one.
Wait a minute, do you think in memes? Is that like the way that you learn? Like you just pull up, like if it has white text below it, then you can understand it, and if it doesn't, then you can't?
You know what textbooks these memes, right?
Wait, so to be clear, like do you have like a picture that you can use that doesn't have like the white meme text above and below it and says like get wrecked globe earth? Like is that how you learn, or like is there, maybe, you know what, maybe you're a zoomer. I thought that you were older than me, but maybe you're a zoomer and I need to start like teaching you as if you're like a memer. Is that what I need to do?
Is this an angle of elevation, Blitz?
I don't know what I'm looking at. It looks like is that an eyeball on the bottom left?
You're clinically blind on your life now. Just, you know.
Well, I'm not. I'm on my computer, and it's a fairly small image. So, but yeah, I don't have perfect vision. It's also a little bit blurry. So we have an eye on the left, and then it looks like what's the word on like the diagonal there? What does it say?
Line of sight.
Okay, so that says line of sight, and then what's the word on the bottom?
Horizontal line.
Yeah. Okay. So can you draw a horizontal line even if the Earth is curved?
It would have to curve.
Wait, so you don't think that you don't think that you can draw a horizontal line even on a curved, even off of a curved surface? Like you don't think that's a thing that you can do?
Off of it, but it would be straight still, right?
Yeah, like you can have like a globe, and then you can draw a horizontal line like straight out from your eyes, even if the Earth is a globe.
And then it would gain.
So like that angle there, it looks like you're measuring an angle there, which is like line of sight relative to a horizontal straight out from your eye, and so like that's a well-defined angle. You don't like that can happen on a globe Earth just as much as on a flat Earth. You understand?
Relative to horizontal, is that what you just said?
Yeah, you can draw a horizontal line out from your eyeball.
Is that relative to a flat Earth then, Blitz?
No, it doesn't have to be. It's not relative to a flat Earth. It's relative to your eyeball.
Why is it 0 degrees?
Why is what 0 degrees?
The horizontal. What do
The
you think the
horizontal
angle of
relative to what? Angles are relative.
What's the angle of the horizontal blitz relative to 90?
It's 90.
No, what's the horizontal angle?
Relative to 90, relative to a vertical, it's 90. Of course it is.
No,
it's 90 degrees.
What is the angle of
If they're
horizontal?
perpendicular, by definition, the angle is 90 degrees.
What is the? I'm not asking you what the vertical. I'm asking you what the horizontal is. What is the angle in degrees?
Relative to what?
90.
90's not like a thing that you can be relative to. It's a number. I assumed you meant the vertical. So the angle of the horizontal relative to the vertical is 90 degrees.
Would this be 0 degrees, please?
Relative to what?
90.
90 is not a thing that things can be relative to. That lines can be that you can compute angles relative to. 90 is a number. Hey, so Angel, can you tell me what's relative to green?
Yeah. Look.
Please answer the question.
Is this here? This is a 90-degree angle, right? Two straight lines, correct?
Yep, that's a 90-degree angle.
And what would this degree be?
Relative to the vertical, it'd be 90 degrees.
No, that's 0 degrees.
Relative to what?
Is a protractor here 0 degrees, Blitz?
Relative to the horizontal, yeah. Because it's the same line, so they're overlapping each other.
Oh, flat Earth then.
What? How do you get to flat Earth from a protractor?
It's a flat baseline, correct?
You can draw a line in whatever direction you want. You can measure stuff relative to it.
Why are you assuming a flat Earth in your calculation?
I'm not. You can assume a flat Earth if you want.
Why was the horizontal straight, not curving?
It's not my wallet.
Why was the horizontal not curving?
What horizontal wasn't curving? If you're drawing a straight line, why would it curve?
Welcome to flat Earth. Oh, so if you take an angle of elevation,
If you just draw a straight line out from your eyeballs, it's not going to curve unless you're in a curved spacetime, which of course we are, but it'd be negligible in this case.
The hypotenuse coming off the horizontal, right?
The hypotenuse coming off the horizontal?
Yes.
My guy, go back and take 8th grade geometry. This is such a rough day for you.
Well, then
You know, I know that you hide behind your British accent, or no, you're Australian. You hide behind your Australian accent to make you think, so that people think that you're smart. But man, the stuff that's coming out of your mouth is like worse than a 4th grader.
So then why didn't you school me?
I literally was trying to school you and you didn't understand the lecture notes.
You used a flat Earth in your lecture notes.
The lecture notes don't assume anything about the shape of the Earth. This is a hard watch, Angel. I'm gonna let you go because this is I feel like I'm punching down at this point. I'm sorry, guys. That was probably rude of me. I kid. It's not rude because he's horrible. He's horrible faith, but like it is very funny to keep him on and lecture him a little bit. All right, let's talk to Matt. I actually should probably read some super chats. We'll read some super chats after this. Oh, never mind. He's not coming up. Let's read some super chats and we'll bring up our next guest. I don't know what a flow state is. Does anybody know what a flow state is? This seems to be like a YouTube thing, but I don't know. I don't know what it is. Thank you, though. Think Then Speak and Nina. From Fear's interaction with the $5. Pretty sure I saw this same flat like a pancake argument on a Christopher Columbus themed episode of Looney Tunes. Yeah, look, like flat earthers, they get their talking points from Looney Tunes. High Logic sent a soccer trophy. I don't know what these are. What are these? Oh, these are jewel things. Well, I appreciate it. From Carrie Yost with the $5, definitionally debate pervertry. Yeah, I mean that's definitely what Angel was doing. It's he definitionally does debate. He is a debate pervert. From Kiyako with the $5, when these morons create something like GPS with their understanding of physics, then I'll start paying attention to them. They're unproductive crybabies. Yep, they're unproductive, and they are foundationally at their core contrarians. That's all they are. From Chase Martin Physics with the $5, if the runway is stationary relative to the plane, then the plane would stay the same distance from the runway. Travel anywhere would be impossible. Exactly. He didn't understand Galilean relativity, and it shows. That said, apparently I didn't teach Galilean relativity in my lecture notes, which is a mistake. I should have taught it when I was teaching 9A. I just assumed that all of my students would get it. From L'Oreal Ashley with the 5 Dr. Blitz gift memberships. Very much appreciated, L'Oreal. And all of the 5 people that you just brought up, that you just gave access to the gift memberships, they now have access to my debate notes, which is what I was showing earlier in the conversation. I'll just show you a quick reminder. The debate notes are these. And in fact, it is in this document that you can see these simple questions that I asked Angel of Light if he could solve. But he couldn't solve it because, of course, he can't. But this is part of the debate notes. So 5 more people now have access to those debate notes. They now have access to the members only Discord channel on Discord, and they have access to the emojis. So thank you so much, L'Oreal. From Mr. Jingles with the £5, Angel, I think of myself as a smart guy, but I would never take on Blitz in public. Yeah, I mean, it was a mistake for him to come on and then just dodge away from special relativity, which he granted, by the way. I actually need to note that agreed with special relativity somewhere in the first half. I'll have to find that, and I'll have to make that the clip, because that's actually like a huge admission on his end. From Eron with the $5, wow, Angels of Shite is even more incompetent than I thought. Yeah, so they claim to have all of these like deep thoughts and understand these things, but they just don't, right? From Daryl with the $5 Australian, if we live on a flat earth, what do we need a z-axis for? That's a good point. From Blunks with the $5, the bottom of a protractor is flat, so the earth is flat. Might be the funniest explanation I've heard in ages. That is what he was saying. And so like, I need like a globe in here. I actually saw a nice globe when I was in Rome fairly recently, but it was expensive and I didn't want to haul it back. But like, if I just brought out a globe and I'm like, look, the globe is spherical, therefore the earth is a sphere. Like, is that the argument? From Jessica Transmetal Alchemist, the $5 Australian, flat earthers continue to fail to understand the relationship between the abstract and the concrete. They absolutely do. From Christopher Sanford with the £2, if earth is flat, obviously you're punching down. Oh, good point. Or it's flat earth, obviously you're punching down. Yeah, fair. From Glitterlock with the $20, which is very, very generous of you. Thank you so much, Glitterlock. I'm starting to think maybe the caller is incapable of considering any reference frame but the surface of the earth. It explains all of their confusion. Everything is relative to the surface of the earth for them. Yeah, that is what it is. They just can't conceptualize anything else, which is strange because when they fall asleep on an airplane, they don't think that they're moving at 500 miles an hour, right? From Daryl M with the $2 Australian, the Australian school system is better than this. Indeed it is. From Jessica Transmetal Alchemist with the $5 Australian, first time I've ever heard someone say that Australian accent makes you sound smarter. I guess your taste in accents is relative, eh? Yeah, I mean, the point is if you have a British adjacent accent, which the Australian accent is, which the Kiwi accent is, these are British adjacent. Same with Irish and Scottish accents. These are like, Americans lump kind of all of these together, and then we're like, oh, that must be an intelligent person because they have this accent. I don't know why. It is what it is. All right, let us just gotta pull something up really quick, or gotta move something over. Oh wait, no, that's not supposed to be there. Oh no, I ruined my setup. Oh no. Okay, I think that we're good. Let me make sure that we don't have any guests. We have it. Yeah, it's because they speak proper English. That's exactly right. My hard drive disk, my disk space is low. That's no good. How much hard drive space do I have? Oh, I only have 582 megabytes. Hold on, I need to go delete something really fast. I just need to go delete some old videos, because otherwise, as I'm recording, this recording will not. It won't go through. Which is bad, because I need these recordings. Okay. I think that we're in the clear. Okay, freed up 20 gigs, we're good. External SSD, I know. Okay, we're good. Oh no, we have one more super chat and then we'll bring up our next guest. From In the Life with the $15 Australian, he tried so hard to trick you so he could say welcome to the flat earth, then clip it for his minions. Yeah, that's what most of his debates end up doing. All right, let's bring up our next guest. Let's talk to, well, there are a lot of people who are in the chat. We could bring up Toneb, who said you lost. Tonub, you want to come up? No, Tonub doesn't want to come up. That's a bummer. You don't know what you're talking about? Okay, let's bring up Chuddy and the Great.
Hello.
Chuddy and the Great, how's it going?
How's it going?
I'm doing all right. Chuddy and the Great, what shape do you think the Earth is?
Well, it depends on, because I'm a neo-libertarian philangist, right?
No!
And it really depends.
Let's bring up Bruh Juiced. Bruh Juiced, how's it going?
Good, you.
I'm doing all right. Bruh Juiced, what shape do you think the Earth is?
Frisbee.
You think it's a frisbee? I kind of don't believe you.
Why?
Because flat earthers don't call it a frisbee.
Oh,
Let's bring up this person who has no name. No name, white profile picture. No name, white profile picture. How's it going?
What's up? It's going good.
Glad to hear it. What shape do you think the Earth is, no name?
Flat.
Okay, why do you think it's flat?
Well, it's just when I walk, it's flat. I don't see a curve. And you know, at the ocean too.
Yeah, at the ocean. Yeah.
If we're gonna have this debate first, I need you to, before I give you my points, okay? Because I'm not sure exactly what we're basing our stuff on here. I need to understand what exactly you define as a fact right here. Like, I need you to explain. You talked about the Galilean before. I need you to explain what is based on observations you have made and what is based on papers others have published that you just trust, you know?
Mm-hmm. Yeah. This seems like it's going to be an interesting conversation. Yeah, so have you ever measured anything like radioactive decay? Have you ever seen it?
Sorry, I haven't measured what?
Have you ever seen radioactive decay? I
didn't hear you.
Radioactive decay.
Okay, you know, I haven't.
Okay,
I've seen
do
the
you think that
effects though.
it's-
Actually, I haven't with my eyes. That's why I'm asking you. That's why I'm asking you.
So I've measured it myself. So I've done plenty of experiments. I've done experiments involving Galilean relativity when I was a freshman in college. I've done experiments involving the rate at which things fall under the influence of gravity when I was a freshman in college. I've done experiments involving the wave-like nature of light in using lasers in college. So yeah, I've done plenty of experiments. On what grounds do you have for thinking that the Earth is flat?
Okay. Me. Well, I said that I think it's flat before, but to be honest, it's more that I just don't think it's a globe.
Okay, you don't think it's a globe.
I don't mean that's not a
And
perfect
on
sphere,
what grounds do you have for not thinking it's a globe?
There's mountains.
On what grounds do you have for thinking it's not a globe? You there? All right. We'll move on to the next guest. That's fine. Let's talk to Golden Ratio. Golden Ratio, how's it going?
It's going good, man. How you doing?
I'm doing all right. Golden Ratio, what shape do you think the Earth is?
I know it's not a spinning ball.
Why do you think so?
Well, it's just observed. Just even like when you guys were talking about the 90-degree angle, the 90-degree angle was 90 was only a number because number 1 exists, which would have been 0 first, right? 90 off of what? It would have been 0.
What?
What you guys were talking about earlier. You're talking about 90-degree angles, right?
Sure.
Where'd you get the 90 from first, though?
It's a measurement between two lines.
You know, you had to start from a different number.
Yeah, so you start at one line, say it's this line, and then you measure angles off of that line until you get to 90, and so you can get a 90 degree off of that line.
Yeah, but the 90 degree
You start
is
at
off
0
of
degrees off that line.
Yes.
And then you
he was
get to,
trying
and
explain to
yeah, so that line is going to be at 0 degrees relative to itself.
Everything that's in observable reality it doesn't measure for curvature, bro. That's what he was explaining to you.
Sorry, can you elaborate on that? I don't know what you mean. Everything that's in observable reality doesn't measure for curvature?
Yes.
What do you mean by observable reality? What counts as observations?
I'm not even talking about just observations. I'm talking about in
But
reality.
you said observable reality.
Not measure for curvature. Yeah, because it's
Oh,
in
you
our
can measure-
reality.
you can
It's
measure
in
curvature.
reality too.
You absolutely can
What
measure
I- what
curvature.
I- Before we got into this, I have a question for you, Blitz. So
Yeah, sure.
You're always talking in like third person, like my students, and you're a teacher. But like, what do you mean you're a teacher and you're a student? You're always on here. You wouldn't have time to be a teacher.
No. I was
too?
I was using past tense. So when I was a graduate student, I was an instructor for like 4 years actually, of introductory physics courses. So I was referring to my students, and what's left out is that I had when I was a graduate student. I don't have any students now.
Just looking for some clarification there. Yeah, because I was going to say you look pretty young.
So I'm 32. So when I was a graduate student, when I was between the ages of 22 and 29, for the last 4 years or so, I was the instructor of record for university level physics courses. Does that make sense to you?
So yeah, it does.
Okay.
So like in reality though, how are you utilizing curvature in your, that you could say, oh, you know what, this can prove that I'm on a ball? Like, where's your proof now?
How am I
Where does it say?
I don't understand what that question means. I can give you a whole bunch of different pieces of evidence though if you want.
Sure, we can.
Is that what
try
you're
it,
asking
yeah.
for? So
what makes you believe you're on a ball besides watching like Star Wars as a kid and shit like that? Sorry, my language.
Yeah, I mean, so like, I don't think Star Wars says anything about the shape of the Earth. Star Wars doesn't involve the Earth. Star Wars is in a galaxy far, far away, a long, long time ago, right? But
Is
yeah,
your
so like,
galaxy
I mean,
flat?
we have
In your model, I'm just
2,300-ish years of measurements of the shape of the Earth, and so it's those things.
Yeah. Before you get into your evidence, so did they measure your universe to be flat in your model? I just haven't looked too far into it.
So in the lambda CDM model, the universe has what's called zero spatial curvature. Doesn't mean it's two-dimensional, it's three-dimensional. Spatial curvature means something technical in this sense. It means that the K value is 0. Now to say that means
so
it's
the
flat
universe
is a
is
different
almost
story
measured
than
at
what you
0?
mean as like when you say the Earth is flat, what you mean is that it's like a pancake. The universe isn't like a pancake. That's not what anybody's saying. Does that help clarify?
Is a pancake measured at 0 degrees?
I mean, 0 degrees relative to itself? Everything is 0 degrees relative to itself.
Is it?
Yeah.
So what evidence are you going to show me first?
Yeah, so I mean, look, so it really depends on like what kind of thing you would accept as evidence. I think that's probably something that's compelling for like most reasonable people is like videos and photos. Because most people recognize that, like, you know, if we were in a court of law, you would use videos and photos to try to determine, you know, like these would be very compelling pieces of evidence to figuring out what things are, how things happened. For example, if you have CCTV footage of somebody committing a crime, then that would be evidence that they committed a crime. So, like, for example, if I showed you a photo of the Earth, that would be evidence that the Earth is, and the Earth was spherical in the photo, of course, that would be evidence that the Earth is spherical. But I imagine that you probably wouldn't believe that.
Are you talking about like the NASA photos?
I mean, the canonical one is the 1972 blue marble. Have you seen that one?
But didn't, like, it's already been, like, I thought we already, like, have
you seen the
known
1972
this for
blue marble?
years. Yeah, hold on. I thought we already known for years that they've already said that these were, like, satellite images and they were data imaging, and so it was actually computer.
No, this is just a
made.
photograph from a camera that a guy took.
Yeah.
Like, it's just a picture. A guy took a camera with him on his way to the moon, and he looked back and he took a picture of the Earth. This was in 1972.
I can't see it. You're small.
Oh, you should. without leaving, you should minimize the app and then reopen it. Did that fix it? Can you hear me?
No, it didn't fix it. But no,
okay, then
it
what you
didn't
can do
fix
is you
it.
can disconnect, close out of the app, and I'll bring you back up. I'm not going to like leave you in the guest box. Just disconnect, close out of the app, reopen the app, reconnect, and then you should be able to see it. Haha, now I'm going to move on. No, I'm kidding. I'm actually going to wait for him. We'll give him a sec. He'll be here. There he is. Welcome back. Is it working?
Yeah, I can see it now.
Okay, so this is the 1972 Blue Marble. It was taken by, was it Michael Collins? I want to, no, Michael Collins, it's not Mike. Isn't Michael Collins a musician? I don't know. It was taken by an astronaut in 1972 on his way to the moon, and I can never remember the name of the guy who took it. But this is a photograph taken by just a regular camera. I mean, it was a specific kind of no, Phil Collins is the musician. Michael Collins, I think, was the guy. No, it wasn't Michael Collins? Okay, hold on. I can go figure out who took the photo.
So while that photo was being taken to the general populace, was the populace still?
It was taken by
saying that it
Harrison
was a
Schmidt.
ball?
Sorry, one more time?
I noticed in like the past decade they changed their narrative. It's no longer a ball, it's actually an oblate spheroid. So
A ball is a kind of oblate spheroid.
Oh, okay.
Yeah.
Okay. So yeah, this photo, yeah, I to be honest with you, like, I don't believe it.
Why not?
That's not, well, it's just not in. I've seen better movies, I could say. Right?
I don't understand. I don't understand how I've seen better movies makes this photo not real.
Well, because there's people that have taken up their own cameras and they've gotten a flat horizon.
Yeah, none
That's
of them
not-
have been 17,000 miles away.
Yeah, but where's his proof of being 17,000 miles away?
There were radar, or there were like radar or radio transmissions that were tracked by like third parties.
So that was past. So he got through the Van Allen belt. That guy is what.
Yeah, you can get through the Van Allen belt. It's not particularly dangerous.
Really?
Yeah.
And what temperature?
You wouldn't want to like live there, but like you can get through, no problem.
What temperatures do they gotta fly through, orbit through?
It depends on which part of the Van Allen belt, but it's very, very hot. But it's like,
Well,
it's also very, very
let's start at the
sparse.
beginning. Is it? Is there a beginning temperature that they're gonna incur? Like, what's the beginning?
I mean, like, it's just a region. I think it's like a few thousand degrees or something like that. Like, is probably the correct order of magnitude. Yeah, a few.
1,000.
Yep.
And so for how long?
Like, I don't know. I don't know for Apollo 17. I don't know. I know for Apollo 11, it was like 45 minutes each way.
So these aren't even, you don't even know the answers to these questions, and you're
I can
just
get you I can find the details for you. I don't know I don't know on the offhand exactly how long Apollo 11 spent traveling through the Van Allen belt. If it was anything like Apollo 11, it was like 45 minutes each way. It was like about an hour.
Well, think of it like this, what you were saying earlier, right? Like if someone brought this photo up front and they said, look, this is proof that we live on a ball. Okay, well, now we've got to go through the evidence. Now we're going through the Van Allen belt.
Yep.
You should want to know these. If you believe this photo
Well, I told
to
you.
be
So
true, you should
look,
have already
we can
gone
just
through
Google
some
this.
of
This is
evidence
so we can just Google this. How long did Apollo 17 spend in the Van Allen belt? We can just Google this, and I imagine it'll be about an hour because it was probably similar to Apollo 11, but I don't know offhand all of the mission details of all of them. Okay, so it spent 15 minutes traversing the inner Van Allen belt and less than 2 hours in the outer belt for each leg of their round trip. So make of that what you will. I was right. It's the same order of magnitude as an hour.
And what temperatures were they?
A few thousand is the correct order of magnitude.
How much pressure was there?
Basically zero.
Zero pressure.
Basically, it wasn't exactly zero. It was quite zero. It was quite close to zero, though.
And what year was this in?
This was 1972.
Well, jeez, man. I know cell phone. The 70s were the hippie days, man.
Yeah.
Just when movies were getting good.
Well,
Right.
have you seen CGI from the 70s?
They didn't even have cell phones to that point.
They didn't need cell phones. What do cell phones have to do with taking a camera into space and then
your
taking a
basic-
picture?
Even your basic American home didn't even have a computer. Windows 90.
What does that have to do with? You're right. So this would have been really hard to fake. What does this have to do with a camera? You know that cameras have existed for like more than 100 years, right?
How did they even exist to do that?
Sorry, one more time. I didn't hear what you said.
In order to, you're just believing the photo. Let's try and go through the evidence, because right now what you said,
Mhm.
they said they spent about an hour. in
Yeah, that's the correct
temperatures
order of
what,
magnitude.
A couple thousand degrees.
Yep.
In the 70s.
Mm-hmm.
So
what does the
was
70s have to do with this?
What was their shell made out of?
Oh, you wouldn't, like, I mean, of course you would suffocate because there's no air up there, but if you just hung out there for an hour, you wouldn't burn. With no protective equipment, you wouldn't burn, because there's basically nothing up there. The stuff that is up there is a few thousand degrees, but it's basically nothing. You know how, and I'll give an analogy because this will help explain things, I think. You know how, like, if you get like boiling water on your hand, you will get like a severe burn?
Yeah, I'm here.
Boiling water is only 212 degrees, right? Like that's the temperature at which water boils. And so if you get that on your hand, it will be a severe burn. However, if you stick your hands inside an oven to like pull out a cake or something, if the oven is 400 degrees, you won't get burned at all, even though you're sticking your hand in the oven. Why don't you get burned when you stick your hands in an oven, but you do get burned when you get boiling water on your hand?
Are you saying because space is a vacuum, they're not gonna?
Just answer the question really quick. Rather than trying to like predict what I'm going to say, just answer the question. Why don't you get burned when you put your hands in when you like reach into an oven, but you do get burned when you reach your hands into boiling water?
It's the matter around your hands, right?
Right. So there's less matter around your hands in an oven because it's gas, it's less dense, so there's less of it, than there is when you stick your hands into water, because water is pretty dense. There's a lot of it. And so if you're out in the Van Allen belt where it's nearly a perfect vacuum, there's basically nothing at all. So even though the stuff that is there is very, very hot, there's basically none of it. It'd be like sticking your hand in an oven that has no air in it. You wouldn't get burned.
You would if you touched the bacon on the pan.
Yeah, but the bacon is solid, right? But we're talking about just existing in the air inside the oven.
If you're accelerating through the air, aren't they flying? They're orbiting?
Yeah, and still, the only thing that's touching them is this really, really sparse gas inside the oven.
That's a big story. You gotta believe, I guess.
It's not something that you gotta believe. It's basic inductive reasoning. If you can understand why you don't burn your hands when you stick your hands into a 450 degree oven, but you do burn your hands when you stick them into 212 degree water, then you can understand why they wouldn't burn if they're traveling through basically a pure vacuum.
An oven has nothing to do with taking a rocket into space.
I mean, the point is that the rocket is being is being exposed to basically a vacuum, but the failure to be a vacuum is very, very hot, and your hand is exposed to a lot of air particles. So there are, for every one particle in the Van Allen belt, there are a billion particles in the oven. So there's no amount of, I mean, practically speaking, there's no amount of time that you could spend in the Van Allen belt where the temperature would hurt you.
Yeah, you're just claiming that you would not.
I've explained it to you now. I've explained it to you using the analogy of the oven versus the water.
There's a video even of them trying to even make a vacuum effect and have an astronaut in it, and he collapses.
What are you talking about? What does that have to do with the claim of the Van Allen belts being too hot?
This is before they apparently sent a guy out there.
What does this have to do with the Van Allen belt being apparently too hot to exist in?
Because even before
It's like a
they
huge
get to that
deflection.
even before they get to that temperature, they gotta explain how they can handle that pressure on the body.
Yeah, there is no extreme pressure on the body because
evidence.
they're in a space capsule. There's air inside the space capsule.
A capsule.
Yeah, there's air inside of it.
Apparently.
Sorry, how long are they up there for? I mean, I think it's like a week.
A week.
Yeah. On that order of magnitude. How long was the Apollo 11 or Apollo 17 mission? It was 12 days. Okay, it was 12 days, not a week.
Yeah, so 12 days.
Mm-hmm.
In like what type of temperatures was in the vacuum of space?
Wait, are we talking about the capsule or the vacuum? Because they were inside a capsule, so it wasn't like.
Well, they needed to heat the capsule, correct? To like.
Not really. The sun would do a good job of that. I mean, probably they actually have to cool it depending on what time of day it was.
Cool it.
Yeah, because the sun's really hot. The sun makes things hot.
The sun's really hot, but as you go up, it gets less in temperature.
The sun's temperature doesn't change. Are you confused?
Well, like if you observably yourself go up into the sky, is it going to get warmer even though you're getting
yeah. So the air will get cooler as you get to higher altitude. Definitely, that's true. Up to a certain point, up until you get to the thermosphere, and that's just because the reason why the air is warm is because of the ground, right? The ground heats the air.
Exactly my point. So
the sun can heat objects that are not so. Air is transparent, right?
What's an object?
You can see through air. Like the space capsule is an object, right? It's a solid thing that the sunlight can hit and heat up.
Okay, so basically, like people that observe in reality, like if they took a hot air balloon, surely as they would rise, get closer to the sun, they would get warmer, right? And hotter.
Well, so what is true? What is true? I'm explaining. Golden ratio. What is true is that the balloon will absorb sunlight. And it will also, depending on what temperature it is, it can either heat up or cool down depending on the air that's bouncing off of it. So you know how if you blow over hot soup, it can cool down the soup. So if you're in a hot air balloon and there's wind, that wind can cool down your hot air balloon. And in fact, generally, the hot air balloon will be quite warm because you have fire underneath it. So you want it to cool down. And fortunately, the air a few thousand feet up is quite cold. So it'll do quite a good job of cooling down your hot air balloon.
Basically, the higher we get, the colder it's going to be.
Well, yeah, the air gets colder, but the sunlight doesn't change temperature. The sunlight is just the sunlight. And if you absorb sunlight and you don't have any way to give off heat, then you're just going to get hotter and hotter. Right. I mean, like this, if the sun gives you heat and you don't have any way to get rid of it, you'll just keep getting hotter.
What's the moon's temperature? The sun's always hitting that every day, right?
Depends on which side of the moon you're on. If you're on the day side, it's very, very hot. If you're on the night side, it's very, very cold.
Can you elaborate on that? What's the day side and what's the night side?
The day side is the side that's facing the sun. Just like on Earth, the day side is the side that's facing the sun. Hey, so I've let you interrogate me for a while. Maybe we can do something a little bit simpler. Are you have you ever seen like a sunset on a cloudy day?
Sure.
You know how like the bottom of the clouds are like orangish or pinkish or reddish?
Yeah.
Have you ever seen that? Have you ever seen that same phenomenon from above? It's kind of beautiful.
Yeah, of course. I've been on flights. I've seen it.
Yeah, so just for everybody who hasn't seen it, in case they haven't, this is what it looks like. Like it's dark on top, and it's like lit from the bottom, right? Like it's like this reddish glow. And so like this is what's happening. Like you can see where the sunset is. The sunset's over here, and so you can see that it's like reddish on the bottom and it's dark on the top. Now, and of course we can see the same thing from above, or from below rather. If this link will open. Come on. Okay, the link won't open. Well, we've all seen sunsets. Sunset on cloudy day. Okay, we can just Google this. Here we go. Lovely cloudy image, right? They're bright on the bottom, right? And they're grayish, darkish on the top, right? Now, what I'd be curious about is if the Earth is flat, then it seems like the sun should be higher than the clouds, right? If the sun was lower than the clouds, then you could just like fly a plane into it. So wherever the sun is, it should be higher than the clouds are, like way higher. So high that a plane couldn't get there. And yet somehow, at sunset, the sun is able to light up the bottom of the clouds without lighting up the top of the clouds. And I just don't know how that is supposed to work if the sun is above the clouds. Can you explain that to me?
Yeah, it's the perception, man. So
what's the perception and what's actually happening?
It's just where the photo is being taken, right? Like you got to understand, like the sun is like a light. We don't know exactly what it is, but we do know for sure that it projects light. We know what as it leaves.
So light comes from the sun, right?
Yeah.
So like
exactly.
So what exactly is happening? Why is it that like at like around sunset, why is it that like the bottom of the clouds are illuminated but the top of the clouds aren't?
How high up are the clouds in the sky?
Let's say that they're normal height, so like a mile or two perhaps.
It'd be nice to get coordinates with this photo so we can go off of.
We probably don't need to know how high the clouds are to know that the.
Well, I think you would want to know it if you're trying to claim it to.
I don't think we need to know it. I think we can just use relative location. So look. So the sun is whatever the sun is. Maybe we don't know what the sun is, but whatever it is, do we think it's higher than the clouds? Like, do we think that it's like actually above the clouds?
But again, like that's what I'm gonna say is like, at some point in the day it could be, yeah.
Do you think that it changes height? Like it actually moves up and down over the course of a day?
In relative to what position and where?
Well, I just mean like relative to the so like the sun is above some point on Earth at any time of day, right?
Sure.
So like relative to that point on Earth, is it getting closer to that point or further away from that point as it moves? As like because
as it gets closer, I think as it gets closer to wintertime in my region, the perception would be is it gets a little bit further every day.
Do you think?
So
well, I'm not asking about horizontal distance. I'm asking about height.
What height? That's what
the
I'm
height
saying.
of the sun.
As it gets closer to wintertime, it's gonna get higher in the
So you would say
sky.
that the sun gets higher in the sky in wintertime?
Yeah.
Like higher above the ground?
Yeah.
Okay, so in your wintertime, I assume you're in the northern hemisphere in the United States, perhaps? Yeah. Okay, so like let's say December, right? In December, you think that the sun is higher in the sky, like it's higher above the ground, than it is in June.
Yeah. 100%.
Okay, but in December, in say Australia, it's summer. So the sun is higher above the ground, but it's summer in Australia?
Yeah, because then it moves out as well as it moves vertical. It's moving east to west too, right? Or north to south.
Sure.
It has to travel. It travels. Like what's that called? An analemma?
Sure. But but just to be clear, so you think that the height of the do you think that the height of the sun changes over the course of a single day? Or do you think it stays at basically the same height each day?
Yep. Each day.
Okay, so then at sunset, it's at the same height as it was at noon, right?
Yes.
So then why is it at noon the sun illuminates the top of the clouds, but at sunset, the sun illuminates the bottom of the clouds.
Because how far would you say it traveled in distance from, let's say, 10 a.m. to 5 p.m.? How far did it travel in
From
distance?
10 a.m. to 5 p.m., that's 7 hours, so it's like a little bit more than a third, or a little bit less than a third of a day. And so it'll have traveled like, I don't know, what's the diameter of the Earth? It's like 25,000 miles, so it'll have traveled like 7,000 miles or so, like across something like that.
What's that law of light? Like, what's the law of light? You were talking about laws earlier, I heard.
I don't think I was talking about laws, but are you talking about the inverse square law?
There we go. Yeah, like what's the law?
It says that the brightness changes. If you double the distance, you quadruple the brightness, or you reduce the brightness by 4. If you triple the brightness, you reduce the brightness by 9. But look, I'm asking about, like, why is it that the bottom of the clouds are illuminated at sunset, but the top of the clouds are illuminated during the day? If the sun is at the same height over the course of a single day, how can it go from shooting light from above to shooting light from below? How does that work?
Because what you got to understand is, I was trying to explain this to you earlier, you have a relative position. So where you are, let's say you're underneath the clouds. You had the sun above you at noon, we'll say, and then 5 hours later, now the sun has traveled 5,000 kilometers away. So now its perception, the light laws work that it's working double as less, but the clouds are higher. No, the clouds are higher to you. Like, let's say the clouds are what?
But the clouds haven't moved up or down.
For you, they stay the same, right? About 10,000 feet in the air. Like,
Yeah,
what's the
say that it's 10,000 feet up. Let's say the clouds are 10,000 feet up. Sure.
So now the sun was above the clouds, which we'll say the sun is at 50,000 feet. Just for this,
sun is 50,000 feet above the ground. Got it. Just for the sake of argument, sure.
When it travels 5,000 kilometers, we'll say west. Then it's going to be lower. Like it's hitting.
Isn't it still 50,000 feet above the ground though?
But it's the vanishing point. Do you know?
But isn't it still 50? I do. Isn't it still 50,000 feet above the ground though?
It's above the ground, but it's vanishing. Do you know how the vanishing point works?
I do. But
Like
to be
at a
clear,
football field.
at 5 p.m., it's still 50,000 feet above the ground. It's just above some other place, right?
It's above another place, correct?
Yeah. So if it's still 50,000 feet above the ground, then it seems like in order to light up the bottom of a cloud, the light would have to like go down and then come back up.
Light does bend. Isn't that measurable?
It doesn't really do this though.
Have you seen observable, measured scientific experiments where they've made light bend? Yes or no?
Yeah, you can make light bend. It doesn't do this in the atmosphere though.
Light does bend though.
But it doesn't do this, right?
Sure.
It doesn't go down and then come back up to illuminate the bottom of clouds without illuminating the top of the clouds. So like, how is it that the sun, even though it's still 50,000 feet above the ground and the clouds are still 10,000 feet above the ground, even though the sun's way over here, it's still 50,000 feet up. How does the light get from here to the bottom? Does it go down and then come back up, or what's going on?
It's light, and it's going to operate like a light, and then it's obviously going on to the vanishing point. So you got to just look
how does it go up? How does it illuminate the bottom of the clouds?
It's just your perception.
Well, no, I mean the bottom of the clouds are receiving more light than the top of the clouds are. That's not a perception thing. That's just true.
Does light reflect?
Sure.
It does.
Yeah.
Okay. Was there water underneath those clouds? Like how? Like we
not in this picture.
For clarification.
Not in this picture.
Are you sure?
In this picture, this looks like the desert. And in fact, if it was reflections, then you would think that the houses would be illuminated on top because it'd be bouncing off of it, right? But in this picture, it's dark, but the clouds are illuminated.
It's a horizontal plane. Like, I don't know what you don't see about that.
But so how is the sunlight reflecting off the ground to illuminate the clouds if the ground is dark?
I'm not making that claim.
Okay, so then why are the bottom of these clouds illuminated?
It's just the angle of where the sun is reflecting, like it.
But the sun is still above the clouds.
It's really just your perception. You don't understand. It's
Well,
like
this isn't a
flashlight.
perception thing. This is like just true. The bottom of the clouds are receiving more light than the top of the clouds. That's independent of human perception. It's just true. You could go put a light detector at the bottom of the clouds and you would get more light than if you put it at the top of the clouds.
Yeah, I don't know how you think this proves your ball.
Well, but I'm just trying to understand how this would work if the Earth was flat.
It would easily work, man.
But how? So why is there more light at the bottom of the clouds than at the top of the clouds?
Because as the sun leaves your vanishing point, it goes to the horizon. That's already
Well,
observed.
I understand that's the claim, but look, the sun. In reality, the sun is still 50,000 feet up, right? And the clouds are still 10,000 feet up. So the sun is higher than the clouds, and yet somehow the light is going underneath. The light comes from the clouds, right? So it should be lighting up the top bit, regardless of how far away it is. It shouldn't be lighting up the bottom bit.
It's an apparent position, it's
right. But the apparent position doesn't affect the trajectory that the light takes. The light just goes from the sun in all directions, right? That's what the sun does. It shoots light in all directions, and so why isn't the sun, even if it's far away, it should still be lighting up the tops of the clouds and not the bottoms? Right? If you have a spotlight or if you have a flashlight and you angle it down, the top is going to be higher than the bottom, regardless of how far away the flashlight is.
Yeah, I'm really not sure how this proves your ball.
Okay, but I'm asking you to explain how this works on a flat Earth.
I already explained to you the light is leaving your vanishing point. So as it leaves, like you said, it shoots in all directions, but as it leaves, eventually it's going to be in your perception lower than the clouds. But just
right,
really
but this
far
isn't a
away.
perception issue. This is a thing that if you just took light detectors, we have instruments that can detect how much light they receive, right? If you take light detectors and you just put them one at the bottom of the cloud and one at the top of the cloud, the one at the bottom of the cloud will get more light.
Yeah, I agree.
It doesn't have anything to do with perception. It's just there's more light at the bottom of the clouds than at the top, and I don't know how that works.
How far away is the cloud from the sun? And it's apparent.
Very far away. Very far away.
Exactly. That's what I'm trying to explain.
But why
to
would
you,
that
man.
make? I don't understand how it. Look. So I mean, just work with me here. Imagine that you have a flashlight or even a light bulb, say, right? Let's say that you have an awning over your backyard, right? And you have a friend who has you have a few friends, your neighbors off to the side. Each one holds up a really bright light bulb. Now, when your next door neighbor holds up a really bright light bulb in a tree higher than your awning, right? So you have your awning, and then you have your next door neighbor has a tree that's taller than your awning, has a really bright light bulb. You shut off all the lights in your house. And they're just right next door. The top of your awning will be lit up or will be brighter than the bottom, right?
Yeah.
Okay, now what if you take that light bulb and you move it to the next tree over, even further away? Which will be brighter, the top of your awning or the bottom of your awning?
Where's the light shining to?
It's still just shining in all directions. It's just a light bulb. It's just now 2 houses down rather than 1 house down.
So it's going to be dimmer,
Yeah, it'll be dimmer. It'll be dimmer. But I'm just asking comparatively, will the top of the awning get more light or will the bottom of the awning get more light?
Did the light's position move?
It's the same height. The tree that it's in is the same height. It's just further away. It's further down the street.
Is that kind of explaining how the sun circuits above us? Because that's what it seems like this measurement of science.
I'm just asking about an awning and a light bulb. And yeah, I can paint it perhaps if that would help.
So far in your experiment, what you've explained to me is the light has stayed the same height, but in relative to itself, but now the light has projected in a different position on the awning, correct?
I don't understand that. Maybe I'll draw a picture and then we can talk about it.
Well,
Would that help?
You're talking about light in this picture behind your face. You changed it now.
Yeah.
And now
I'm just trying I'm just trying to
And
draw a
you're going
diagram
off
here
an
now.
experiment that is actually measurable in reality, and what's so far that you've explained is that it.
So here's my
the flat
house.
Earth way would work.
Here's my house, and then here's my awning, right?
Yep.
And let's just fill this in, right? There's my house, there's my awning. Now, my friend has a tree. Let's use, yeah, it's fine. Pretend that's a tree. It's not a very good, actually, we'll use a different color. So here's our tree. That's my next door neighbor's tree. And he puts a light bulb at the top. He just, you know, he's a funny guy. He puts a light bulb at the top. I don't know, can you see that?
Yeah, for sure.
Okay, now, you've turned off all of the lights, so it's pitch black, right? Except for the light bulb. Now, which part of your awning will be brighter? The top part, like the top surface, or the bottom surface? Will it be... Go ahead.
I guess right now it's going to be at the top, right?
Right, okay. Yeah, I agree. Now, if we take that tree, let's say that your next door neighbor turns off their tree light, and instead the neighbor one house further down turns on their tree light. Okay, did anything change? Is the top of the awning still brighter than the bottom of the awning?
It's actually dimmer.
Well, no, I mean relative to the, I mean the whole like it'll be dimmer everywhere because it's further away.
Yeah. Okay,
but I'm asking about the top relative to the bottom. Which one will be brighter?
Now they're going to be kind of meshed together, and it's going to be.
So you'll think they'll be the same
dimmer.
brightness?
Eh?
You think that they'll be the same brightness?
They won't be the same brightness. Like the top of the awning and the bottom of the awning will definitely be the same brightness, but they'll both be dimmer.
You think that they'll be the same brightness?
Yeah.
So how is the light from the light bulb getting to this part of the awning? So there's this part of the awning. How is the light getting there?
Yeah, there's going to be a small. No, well, you got to keep drawing those lights, like those light lines.
I mean, for the entire bottom of the awning, I don't know how the light's going to get there.
No, but Blitz, you see those three or four light lines that you drew?
Yep.
Is the light just going to stop there, or is
it's going to hit the awning? It's going to hit the awning, right?
But there's going to be continuous lines until you hit grass. So
yeah. And so here's another one.
There we go. Okay.
Here's another one. Here's another one.
There'll be a couple more, but yeah.
But yeah. I mean, like there'll be ones in the middle, of course, too, and then there'll be the ones that go up.
Yep.
All of these light beams, right? But are any of them hitting the bottom of your awning?
Not right now.
Okay, so is the bottom of your awning getting any light?
Not right now, no.
Okay, so the bottom of your awning should be dark, right?
Yeah.
And the top of your awning has some light, even if it's dimmer light, the top of your awning has some light hitting the top, right?
Yep.
Okay, so the top of your awning has some light, so it should be brighter than the bottom of your awning.
Okay.
So it seems like regardless of how far away I move this tree, the top of the awning will always get some amount of light. It'll just be maybe dimmer and dimmer. And your house will get some amount of light, but the bottom of the awning will never get any light.
Eventually it will get light if you keep moving that tree back.
Oh, how far do I have to move it?
I don't know. We would have to test that in observable reality.
Let's do it. We're just gonna take our tree and we're gonna move it. We're gonna pick up our tree. We're just gonna pick it up.
Just be genuine with your light rays when you're doing it.
Yeah, I will. 100%. We're just gonna move it way over here. Okay. You can't even see it yet, but it's way over there, right? I'll make this a little bit smaller so that people on the vertical can see it. And then let's fill in the nighttime, right? So now I have to be really precise, but we can do this. So we have our, and let me make this smaller so that people on the horizontal can see it too. So we have our light ray. So we have a light ray that's going there. We have a light ray that's going there. We have a light ray that's going there, and that will crash into the top of your roof. We have a light ray that's going there. We have a light ray that's going there. Oh, you guys can't even see this on the, there we go. We have a light ray that goes there, and one that goes there, and And so on, right? I mean, like, you know, we could keep drawing these, but those are the relevant ones. I could draw a few more if you'd like.
Yeah, at that point you'd have so many light rays. Like you could draw 5 or 6, but at this point you would have, we'll just say 1,000.
Well, I mean, the number of light rays, you know, arguably it probably doesn't change, but the point is, you know, it just makes it easier to draw these. And we have another going there. And so let's zoom in on our house, right, on our awning. So we still have like some light rays that hit the top. They're very spread out, but some light rays hit the top. Some of them are going to hit the front edge of our awning, right? Some of them will hit this part there. Some of them will hit there, but still none of them are hitting that bottom, right?
In what you're showing right now, no, it's not.
And so it seems like regardless of how far away I make them, you'll never be able to get any that actually hit the bottom.
Yeah, but
because in order to hit the bottom, it would have to come up, right?
Eventually it would, though.
Why?
Because the tree itself will be at a different position in relevance to that house, like the horizon point. You got to understand, every time you keep backing it up, right?
Regardless of how far away it gets, the light...
Hold on a second.
Yeah.
In observable reality, like as that tree leaves, like as it leaves, you know how you keep backing it up?
Yep.
Is in observable reality, like, does the angular resolution of that tree and that light get smaller? Like, do they?
Yeah, the apparent size gets smaller, but we're just talking about reality. We're not talking about like how things appear to be.
Doing this experiment now, when you do this next time, you're gonna back it up one more time. It's got to get a little smaller.
The tree isn't actually smaller. Why would I make the tree smaller? The height didn't change.
In observable reality, it is.
The height didn't actually change, though. So why would I change why would I change the actual depiction of the way it actually is, just because your perspective is wrong? Like things don't actually get smaller as they get further away.
That's just that's just how it works, though.
No, things don't. You think that things get actually smaller as they get further away?
In your apparent perception, yes.
Right, but we're not talking about apparent perception. We're talking about the way things actually are. Right? We're not talking about apparent anything. We're talking about the way the world actually is. And the tree doesn't actually change height. Right?
From that position,
the tree's height is just a tree. It's not shrinking, it's not growing, regardless of how far away it is. It's just the height of a tree.
If you kept moving that tree back, though, eventually it's going to hit the horizon point of that.
How far away is that?
And you're just trying to make this argument for like the clouds. And the thing is, you're looking at a tree that's, we'll just say it's 20 feet up in the air, and you're looking at a garage that's got like an 8-foot stoop. So
yeah. So I'm using this as an illustrative example.
Inequivalent to.
Oh no, it's exactly equivalent. The geometry is identical. I could have replaced this garage, this awning, with a cloud. I could have just drawn a cloud here instead, and I could have drawn the sun not standing on a tree over here, and it would have been the exact same. The point is that no matter how far away it gets, because, you know, the tree doesn't actually change height, no matter how far away it gets, the light will always be coming down at a slight angle, which means that the light will never be able to come up and hit the bottom of the awning. There's just no ifs, ands, or buts about it. It's just not geometrically possible. And so what that means is that on a flat Earth, either the sun has to go physically lower. If I did shrink this, if the tree was shorter than the awning, then indeed it would illuminate the bottom and not the top, which would mean that the sun would have to get physically lower. Right? It would have to get physically lower, not just from perspective. It would have to get physically lower over the course of a day.
But we observe that in reality, right? Like, as something goes farther,
you're right. We observe the sun not getting further away. We observe the sun getting lower. That's true. But that's because the Earth is a globe, not because the Earth is flat.
I'm talking about trees, the one you just showed us. That tree is going to appear to get smaller as it gets further away, correct?
It will appear to get smaller. It won't actually get smaller. It's an important distinction.
But it'll appear to get smaller, correct?
Right, but we're talking about the tree would have to actually get smaller in order for it to illuminate the bottom of the awning. I have something that might help you. Let me pull it up really quick. I don't know, maybe this will help you. Maybe Father Ted can help.
Okay, one last time. These are small, but the ones out there are far away. Small, far away. Forget it.
Did that help at all? That even if things are small, they're
The thing
not.
is, I don't need the help.
They're just far away. They're not actually small.
I know how light works. That's just the
So
thing.
when the
man.
tree looks small, is it actually small? Or is it just
You're right,
far
I'm looking-
away?
At the horizon, it looks to get smaller at your vanishing
Right, but is it
point.
actually small? Or is it just
You
far
already know the
away?
answer to that. It's just further away, but the light itself has to follow the light laws, like the inverse square light
The
law.
inverse square
right?
law doesn't say anything about the direction. It doesn't tell you that it appears to originate from some lower location. That's not what the inverse square law says.
No, but it gets dimmer, which
It
we
does get dimmer.
observe.
That's true. The whole thing gets dimmer. I agree. But it doesn't make it appear
And it gets
lower.
further away,
It
correct?
doesn't. It doesn't get actually lower.
Is it moving at thousands of kilometers in a day, though?
I mean,
What's
that's your view. I don't think that that's true. But you know,
What do you mean?
on the flat Earth world, sure.
Flat Earth world. Let's talk your world. How far does the sun travel in a day?
The sun doesn't travel. We rotate.
So the sun doesn't move at all.
No. We just
So we're not
we move. From our perspective, it appears to move because we're moving, but it doesn't actually move.
So the sun
Relative to the
itself
center of the sun,
doesn't
anyway.
move. So the sun isn't traveling in the universe; it's just staying in the same spot.
I mean, relative to some other stuff, it is. But like, you know, as far as the solar system is concerned, the sun isn't moving, and we're moving around it, and we're rotating relative to it.
I'm pretty sure the sun has a path.
I mean, relative to like the center of the Milky Way, sure, but that's irrelevant.
Well, no, it's got to have some sort of acceleration in your model.
Here, I want to show you.
Like in your model, what type
Hold on,
of acceleration?
hold on. I want to show you something.
In relation to wherever it's heading.
I want to show you something really quick. I just want to find the right diagram for this.
Why are you jumping away from that?
No, this is about the this is explaining how it works on the globe model, right? So here's how it works on the globe model, right? So you have the clouds above. This is obviously not to scale, but you have the clouds above the surface, and the clouds. It's not drawn this way, but the clouds surround the Earth, right? So there will be clouds over here that the sun is directly above that are going this way, and then there are the clouds over here that the sun is not directly above because the Earth curves, and so it'll illuminate the bottom. Does that make sense?
Sure.
So it works
that's what we're
perfectly
seeing,
well. The diagrams are fairly straightforward on a globe. I don't see how it works on a. I don't see how it works on a.
It easily works on a flat
plane.
Earth.
But I don't know, man. It didn't seem like you were able to give me an explanation.
Well, it's just because you don't understand the basic laws of light and how when it gets further.
You didn't
away
even
from
know what
you,
it was
it's
called. I had to help you. What do you mean I don't understand the basic laws of light?
It's not about you knowing what it's called, man.
Well,
It's just
clearly,
the
if you
reality
didn't know what it was
that
called, then I don't think that you have a
reality
strong
that you're
ethos
living
here
is just
to make a point that you know better than I do about this.
Because it's not. It doesn't break down to education, bro. I hate
Clearly,
to
it
tell you.
does.
No, it doesn't, though.
Are you sure? Because
I'm
it doesn't.
positive.
It seems like you're confusing the laws of perspective with the laws of optics. These aren't the same
Like
thing.
Star Wars came out, and you just a bunch of you guys just grasped onto it.
You know that we've known the Earth is a sphere for 2,300 years, right? Calling back to Star Wars is not a good look for you.
That's a false claim. 2,000 years ago, you weren't around, Blitz.
Oh, we have writings from 2,000 years ago, though.
It doesn't matter that we have writings. That's fine. People have.
Do you want me to show you them?
Some people are 13
Want me to
some
show you
people are
them?
14 generation Blitz.
Want
So
me to
some
show you
people
them?
actually have family experience that know that the Earth is flat.
So do you know who Pliny the Elder is?
Like, just because you became an atheist, Blitz,
Do you know who Pliny the Elder
North
is?
American as a whole, everyone used to have a Bible in their night table.
That's cool. Do you know who
That's
Pliny
just
the
a
Elder
fact.
is? That's cool. Do you know who Pliny the Elder is?
Page 1. There is waters above and there's waters below.
Right, and the Bible
It's
is wrong.
2026, bro. We can measure and we can see that water.
You're right. It is 2026, and you still think the Earth is flat. Do you know who Pliny the Elder is?
No, it's not. 2026, and I still think the Earth is flat. You're just being.
I know it's 2026, and you still think the Earth is flat. Do you know who Pliny the Elder is?
Talking in third person about your students, but no one ain't paying you
Talking
to be
in
a
third
teacher.
person?
I can assure you that.
Talking in third. I was talking in first person the whole time. Do you mean in past tense?
Okay, sure. Past tense.
Okay.
No one's
Bro doesn't
paying
know
you
the
to be a
difference between third person and past tense, but he thinks that
Be
he knows
honest with yourself. No
the
one's
laws of
paying you to be a
optics.
teacher.
I was literally paid to be a teacher between 2018 or between 2019 and 2022. I was literally paid for it.
Yeah, I don't know who was crazy enough to do that.
It was the University of California, Davis.
Yeah, that makes sense.
Yeah, that a major national university paid me to teach their students. Yeah, it does make sense because I know what I'm talking about. So do you know who Pliny the Elder is?
No, I don't.
Okay, he's one of our best early historians. So he was a Greek. Actually, I think that he was technically Roman, but he was a European, very early historian, lived about 2,000 years ago. This book that he wrote, The Natural History of Pliny, is from 77 CE, or 77 AD, as you might want to say, meaning that it was, 40-ish years after Jesus lived. Now, this is a translated version, of course, but we can go to page 50, or technically it's page 16, but we can go to page 50. This is chapter 2, Of the Form of the World. Now, again, this is from 2,000 years ago. That it has the form of a perfect globe, we learn from the name which has been uniformly given to it, as well as from numerous natural arguments. For not only does a figure of this kind return everywhere into itself and sustain itself, also, including itself, requiring no adjustments, not sensible of either end or beginning in any of its parts, and is best fitted for that motion with which, as will appear hereafter, it is continually turning round, but still more because we perceive it, by the evidence of the sight, to be in every part convex and central, which could not be the case were it of any other figure. So this is from 2,000 years ago, a historian saying that the Earth is a perfect globe.
What did he measure in 2,000 years ago? What tools did he use to measure the
He's a historian, not a scientist.
A piece of paper, but you're not believing the Bible.
He was a historian.
In every single American
He
home.
mentions from numerous natural arguments.
You say you're 32, Blitz.
I am 32,
in the 90s, when you were growing up in the 90s, when you were 7, 8, 9, 10 years old, at least 90% of households carried a Bible. The Bible
I don't think that's true.
Well, whatever then. That's just
So
your belief.
did you just make it up?
I didn't make it up.
So where'd you get the 90%?
That's what do you think Americans' traditional value is?
You know that 90% of Americans have never been Christian, right? Well, at least not 30 years ago.
So on what religion was America created on?
It was created as a secular nation, perhaps deistic. There is no official Church of America, so it doesn't have a state religion.
Church of America. That wasn't what I was saying. You guys have values.
What are you talking about?
Have Christian values.
Well, I mean, yeah, you're right. It was created on Christian values, including slavery, but that's neither here nor there.
No, now you're just bringing up false claims. That's just baseless.
Well, I mean, the United States was created on the back of slavery, and that is a Christian value,
there.
So...
You weren't there, so you're just talking about history that was told to you.
Oh, do you think that slavery didn't happen?
What?
Do you think that slavery didn't happen?
I never said
okay,
that.
so then why be skeptical? Why express your skepticism about, oh, you weren't there, you're just repeating the history that you were told? Do you think that America was built on the back of slavery or not? This is a pretty basic question.
You're 32 years old. So in your literal life, you've actually watched the news twist things in your own.
So just to be clear, I'm gonna ask you a really straightforward question. Do you think that America, you know, late 1700s was built on the back of slavery?
Okay, Blitz.
Answer the question, scumbag.
Life. No, you already know. Because you already know.
Oh, so right. You don't think it's true. You don't think that slavery was a big deal.
Slavery to this day still exists.
Yeah, I agree. It's bad. Do you think that America was built on the backs of slavery
Why isn't anybody
250 years ago?
It still exists today.
Answer the question, scumbag.
Look, why are you going to personal attacks now?
Because you're denying the existence of slavery. That makes you a shit person.
What'd you just say?
You're denying the horrors of slavery, which makes you a shit person.
Everybody, it's still happening today. Look what's happening in other parts of the country.
Do you admit that it was happening 250 years ago in the United States? Was it happening 250 years ago in the United States?
There's stuff happening today, and you're talking about stuff.
Why can't you answer the question? You keep like, there's stuff happening. Answer the question. Was there slavery happening in the United States 250 years ago?
If you're such a righteous person, why aren't you standing up for the people today?
Was there slavery happening in the United States 250 years ago?
You're just talking about stuff just to talk about it, but there's actual stuff happening.
He won't answer the question. He's afraid to answer the question because he knows that it'll impugn his religious tradition. This is so embarrassing for you. I hope I hope you don't have children, and if you do have children, I hope they hear this and recognize that their dad really has some stuff to work on.
Oh, I think that you're just personal attacking because you're wrong.
Yeah, I'm attacking you because you're expressing shit opinions that show that you're a shit person. This is so easy. Just be like, yeah, there was slavery 250 years ago in the United States, and it was bad.
You don't want to fix the stuff that's happening today.
To be clear, I'm asking you a very simple question. Do you think that there was slavery 250 years ago that helped build the United States?
Your ancestors were probably slave owners.
Oh, no, they weren't.
I wouldn't be surprised.
My ancestors didn't even live in the United States prior to the 1880s.
I'd like to see the proof of your family tree, because I got mine.
My first ancestor got to the United States in the 1880s.
You were a slave owner. Don't ever get it twisted.
Well, I certainly wasn't. My ancestors lived in didn't move to the United States until the 1880s.
Existed in your country? Well, you were a part of that. Look at your skin color.
No.
You're claiming, your whole claim is white people were slave owners to black people, right?
I didn't say anything about white people.
You're trying to make it out like I'm the bad person?
I didn't say anything about white people. Somebody's crashing out because they think that I'm impugning his race.
You're calling me a scumbag for nothing because you're wrong about something.
You're being a scumbag by not being able to acknowledge that slavery was like a bad thing that happened in America's history. Like that's crazy. That's like scumbag behavior.
A bad thing that happened. I never said it wasn't a bad thing.
You never answered the question. I asked you, did slavery happen in the United States 250 years ago? Yes or no? And you've avoided the question for the last 10 minutes. 5 minutes perhaps.
I didn't deny that stuff like that didn't happen.
You didn't answer the question. There you go, avoiding it again, dodging like a professional dodger. Did slavery happen in the United States 250 years ago? Or 248 years ago?
I believe there's evidence that there was slavery because I can still observe it in today's reality. So yes, I believe there was slavery. It could have been as late as 50 years ago. You're putting a timestamp on it 250 years ago.
Yeah, I was asking a very basic question.
When you look
and for some reason it took you like 8 minutes in order for you to even admit that there's evidence of slavery 250 years ago.
When you look at the buildings in every single big city, yeah, you're crashing out, but every single big city has beautiful buildings that were from 200 years ago, supposed, and we didn't even have power tools then. But you don't even want to explain that. So
you don't need power tools to build nice things, dumbass.
Something that's like bad things are happening to people. There's look at what's happening to the Uyghurs in China right now. Why doesn't anybody talk about that?
Lots of people talk about it.
Slavery that happened in one spot. Look what's happening to the Chinese Uyghurs.
He wants to deflect so hard away from the Christian tradition of slavery in the United States.
You're just bringing up slavery when we're talking about flat Earth because you have no proof of a globe.
Oh, I mean, I think that we can leave it up to the chat and to the comments who will be watching this in the future. Hi, YouTube, about whether or not I've proved it's a globe. But I think that this is probably enough, right? Like at this point, you've deflected off of slavery for like 8 minutes, and then you failed to explain anything on the globe, even the simplest of observations. So, do you want to call it here, Golden Ratio, or do you want to keep crashing out?
I was around for the 90s, 2000s, 2010s, 2020s, so I can explain some of that's happened in history.
Yeah, so Golden Ratio, I'm gonna give you. How about this? I'm gonna give you 60 seconds so you can have your final say, and then we'll call it there. Okay.
Yeah, for sure, man. I can only observe what I've been in my reality.
He fell for it. Why would he think I would do that? Like, that's, why would he think? Okay. All right, let's read some super chats and we'll bring on our next guest. From Binary Ghost with the $5. Okay, fine, the Earth is flat, but why do none of these people talk about how thick the Earth is? Also, I heard you lost. How does it feel to lose? Indeed, how does it feel to lose? How does it feel to lose? Golden ratio. No, that's a good bit. From Squeaky Eyes with the 5 Canuck bucks. Universe is flat in the sense that we can draw straight lines to other objects. FLERFS will jump on the flat term, though. Of course they will. Yeah, that's what it means. It means it has no intrinsic curvature. From Binary Ghost with the $5. What is on the bottom side of the flat Earth? Is the flat Earth just floating in space? Does it spin like a record? What happens if you tilt it? Oh, well, they don't think that space is real, of course. From Glitterlock with the $5. How did they even exist to do that? Answer that, Dr. Blitz. Oh, you got me. You've got me. From Squeaky Eyes with the 2 Canuck bucks. Okay, so can guest explain it better? Refute it. Yeah, the thing is this is something that flat earthers can't account for, right? Like, this is just a reality. And look, there are so many like sophisticated demonstrations that the Earth is not flat, that the Earth is indeed a globe. But this one is so simple that anybody with like a basic understanding of anything would know that this shows that the Earth can't be flat, which is why I use it, because this is accessible to even flat earthers. From Shag, though, with the $5, when your mommy reaches into the oven to get your Hot Pockets while you're playing Fortnite, she doesn't burn her hands. If she touches bacon, flat Earth. Incredible. Incredible. From Binary Ghost with the $10, it gets colder as you get higher in the sky. BS. It's clearly demonstrated in the story of Icarus that it gets hotter. You dirty atheist science worshippers always trying to get people to deny Helios. True, you got me there. You can't fly too close to the sun. From Chase with the $10, I know we joke about FLERFs being dumb, but these people have seriously low intelligence. They aren't normal people that were duped like religions. They are incapable of getting the simplest concepts. Yeah, that is a serious concern that I have. From Jack Fetter with the $5, flat Earth arguments are already dumb, but when argued by a dumber than average FLERF, they sound so pathetic. Flat Earth really is dead. It is dead. From Binary Ghost with the $5, more Helios denial from both of you and this caller. The sun is carried across the sky in a chariot. What's so hard to understand? You know what? Give me the evidence and I'll be convinced. From Cassetio with the $5, Blitz, it's all about the sunrise. On a cloudy day, the sunrise hits the bottom of the clouds, but an hour later after sunrise, the clouds are dark. Yeah. From Optopoppet with the $5, when these goobers bring up perspective, we should show them MC Escher's print gallery and ask them where the gallery begins. That's a good question. That's a good point. That's definitely a good idea. From Jack Fetter with the $5, even FLERFs understand light will never be from below on their pizza. Just pure cope and denial or else the world crumbles. Hashtag intellectual dishonesty. Yeah, I don't know if he knew that. From the J-Pump for your patience with the $5 is very appreciated. From Binary Ghost with the $5, listening to this makes me want to stop doing drugs and alcohol. I don't know how much it takes to get this way, but I don't want to find out. Yeah, I really hope that that's not what happened here. From Mike Angel with the $5, thank God for light physics, or we might have missed perineum sunning. Don't sun your taint, y'all. From Morton ST with the 100 Norwegian kroners, here's some funding towards your education on light laws Blitz. Yeah, apparently I need it. From Jack Fetter with the $5, lawyer, I rest my case. Court, your argument is flawed and incorrect. Lawyer, well then, whatever. It's so bad though. From Zetal Fakapa with the $10, you weren't there for history, so you can't make arguments from it. Simultaneously, Bible history, which happened thousands of years before my life, is completely valid. No brain cells utilized. Yeah, that was a weird one, and I should have caught on it. From Binary Ghost with the $5, haven't you watched the hit Disney movie Song of the South? That whole unpaid labor thing didn't seem so bad. Zippity doo-dah, zippity yay. That, ooh. Yeah, I mean, they probably think so, but... From Astro Adventure with the $2, anyone think the caller sounds like Skeleton Man? He did sound a little bit like him, yeah, I agree. And our last super chat for now from Fuzzy D with the 15 shekels. Wildly disagree with the chatter saying FLERFs are innately unintelligent. Very dangerous way of thinking. I've seen someone become this sort of person. So look, I think that, like, look, there obviously intelligence is a spectrum for the human population. And so there are going to be people on the low end of the spectrum. That's absolutely true. And so what seems to be the case is that it's at least possible. I would suspect that people who are closer to the lower end of the spectrum are more likely to be duped by flat Earth than people that are not. And from enough data with the $5, have you considered using Space Engine for demonstrating sunsets and curvature? I haven't, because it wouldn't be able to model a flat Earth, right? All right, I need to take. I feel like I'm not supposed to take a leave this regularly, but my sinuses are killing me. Yeah, okay, we'll take one. I really should joke about how this guy's causing me a headache, but no, it's a sinus infection that's been lasting forever. Don't mind me. Okay. Don't worry, it was just a leave. And it does seem to help a lot. Yeah, it's just a leave. Yeah, my chakras are off. Right, you got me there. All right, let's bring up our next guest. You're like +3 volume on all guests? Good. Good, I want to be louder than them. Oh, God. Really hurts. Hurts a lot. All right, let's bring up Edgar Ali Brecht. That's a hell of a name. Edgar Ali Brecht, how's it going?
So, one question.
Before you
What
start,
happened?
do you think that the Earth is flat?
You know why I say the Earth is flat.
Well, I'm just asking if you think that the Earth is flat.
Remember, I attacked you with my last centrifuge and vacuum experiment.
I don't remember, you know.
You all remember you have no answer and you kicked me because you know
No,
that
I don't remember.
You have... Oh, you remember? You can check it on my profile. It's a photo from you, and you can check this video.
Let me go look through my videos.
Yeah.
What was your name then? Because I don't recognize your name.
Edgar Ali Brecht.
I don't see it anywhere. Maybe you weren't notable
I
enough
remember.
to upload.
Yes, I bring arguments that we build a room with vacuum, a centrifuge, and we simulate 1000 G.
Yeah, I don't see it anywhere. But if you're saying that we've
gravity
spoken
is
recently,
not-
then you're saying that we spoke recently? How recently?
My English
How
is not
recently
the
did we
best.
talk?
For 2 weeks, maybe.
Okay, then I'm gonna let you go. Another time. From Mike HT with the €5. Greetings from Italy. A little gift for you because you're talking to this guy, so we don't have to. I would surely snap if I was in your place. Fair enough. I appreciate that. I do remember Discord guests, but we have a lot of TikTok guests that were there first. Like US Dark Maga US.
Yep. How long was your
Dark
discussion?
Maga, how's it going?
What's up? How long was your discussion with Angels of Light?
It was 49 minutes.
Okay. Well, I challenge you to debate on modern day debate.
I already have.
Instead of. Really?
Yeah. Yeah, I can show you. Let me pull up the video.
Because like I joined in like the last 10 minutes, and I just saw you kick him when he was trying to explain something. And I just the first thought that came to my head is, wow, like Blitz, you're really
Here you
you become bad faith.
Angel of Light is a known bad faith interlocutor, and I've debated him many times. So here's the video.
But he was being very cordial with you.
No, he wasn't. He was intentionally strawmanning me. Here's the video if you want to watch a modern day debate. It's from about a year ago. It was me and Mark Reed versus Nathan Thompson and Angel of Light. It's an embarrassing show for Angel of Light and Nathan Thompson.
Okay, well, why didn't you want to give him a chance this time? Like, that was a year ago. He's probably
Because he's
got you up.
no. I think I've spoken with him since. He's a known bad faith interlocutor. Like I know him. I know him not personally. I've spoken with him many times. He's like super bad faith. He's like intentionally bad faith. He intentionally strawmans. I'm not gonna be charitable with him. No, of course not. Anyway, do you think that the Earth is flat?
Yes.
Okay.
But
let's talk about it. Why do you think that the Earth is flat?
Well, we have a model. Have you seen it?
You have a model. Oh, you have a model now. Okay. What's the model?
FE conceptual model. Then it's GitHub on Google.
Yeah, let me pull it up.
No, I wanted to respond to something that last guy came up here. You mentioned slavery.
Oh, from Alan? Yeah. Okay. So great. We can. Do you want to talk about this model? This is cool. This is great.
Yeah, I do. But I just gotta say, slavery is way blown out of proportion. Like, not that many white people owned slaves, and it was mostly Jews.
Well, that's not true. That's not true, and that's like a crazy claim. But also, do you want to talk about the model, or do you want to do like anti-Semitism plus slavery denial?
I mean, it's
because we can do both. We can do whatever you want, but like I imagine that you probably don't have the boots or the brain cells for that hike.
Click the eyeball button on the top left. And
the eyeball button on the top left. I have no idea what you're referring to.
Actually, we pause it and then find the sun.
I don't even know how to pause it. How does one?
Spacebar.
Okay. Cool.
Now find the sun.
Is there like a button to press it?
It'll be in the dome. It'll be in the dome.
I'm just seeing like the constellations.
In the light area. It's gonna be on the dome.
Yeah. I mean, like I know that it'll be like somewhere over here, but like I'm looking. Is there like a button for the sun?
You gotta find it. You gotta put your mouse over the stars and find the sun.
One of these will be the sun.
It's gonna be in the middle of that light area. I thought you said you're good at geometry, man. What's going on here?
I've never seen this app before, and it seems kind of poorly designed, to be honest.
No, it's brilliantly designed. You're not familiar with it, so I'll give you the benefit of the doubt.
Cycle Starfield, open map projection settings.
No,
okay,
you're not understanding. You're not understanding.
Specified tracker mode. Toggle true position markers on the heavenly vault. I don't know where they went.
You're not understanding, dude. You have to go back to your personal
toggle
dome.
Permanent night. Oh no, wait. I don't want to toggle permanent night. I want to swap. Oh no, that's not what I want.
You gotta find the sun, man.
I'm looking, bro.
You fucked it up.
Your app's not making it easy.
Because you got rid of the heavenly vault.
Oh, wait, hold on. There we go. We found it. There's the sun.
Find the sun. Click on it. Now click on it.
Hold on. Okay, found the sun. Cool. Found
now
the sun.
go in the first person.
I don't know how to go to first person.
It's the eyeball button.
Eyeball button. Okay, I'm in first person.
Now press space.
Okay. Wait, hold on. So it's nighttime, right?
Like for you, yeah.
In this first person, why can't I see the sun?
Oh my gosh, you got the wrong sun. You didn't click on the right sun.
Well, no, I mean like the sun's here, and like the first person perspective is like down here, right?
Oh my gosh, no! You gotta refresh. You gotta refresh the website now.
What do you mean refresh the website? What's wrong? What's wrong with your model?
You didn't do it right.
Okay, we'll refresh it.
There's multiple different suns.
Okay, so here we go. I just refreshed it.
You gotta clear your cookies now because it's saving the data that you had up before.
So wait a minute, just to be clear. So this is where I am, right? I'm like in North America. Like if we zoom in, like that's North America. That's like where I am.
That's your character. Yes.
Yeah. Okay. Now the sun is over there, right? This is the sun.
No, you gotta understand because
there's the moon. There's Venus, Jupiter. That's the sun.
Dude.
I'm clicking on the sun. This is the sun, right?
Let me talk.
I'm just asking questions. I don't know why you can't answer my questions.
Do you see how there's a dome, a personal dome, but then there's a stars above?
Yeah. I see the personal dome nonsense. Absolutely, yeah.
You enabled the wrong setting. You want to only have the dome.
I have
get
both
rid of
enabled.
that. You got to find the sun now. Oh no, turn that one off. Turn the big one.
We have the dome, but the sun. Look. So I get that you think that there's a personal dome, but like, look, I'm here, right? I am on the. How does this? God damn it!
You know what?
Is there like a way to like this is so poorly designed.
No, you just. I'll show you.
Okay, so here's me. I'm like in North America, right? I'm in North America. I'm looking around. I'm looking around. I'm in North America, right? Now. So that's where I am.
Blitz, man, you're not being honest here.
Hold on. Chill. 1 sec. So that's where I am. I'm here. The sun's there. It seems like I should be able to have a direct line of sight to the sun. Like there's nothing blocking me from seeing the sun. And yet when I go to my first person perspective, I can't see the sun. Why can't I see the sun? Where is it?
Can you expand me? I know you're on multiple different platforms.
No, I cannot. So can you just answer my question?
Look on my
screen. Why can't I see the sun?
I'm showing you. You have this. You see the personal dome, and you see the sun right here.
Yeah, I can put the nonsense personal dome back.
You gotta look at my screen, man.
I mean, the personal. I can see the personal. I can put the personal dome back. That's no problem.
Look,
personal dome is back.
You see how now I'm tracking the sun moving. Look, and now I'm gonna go on the
No,
first
no,
person.
I'm just wondering, like, why can't I see it if I'm in North America and the sun is over there?
It's because you have the heavenly sun up instead of the sun that moves around above the plane. See,
Wait, so is this the actual sun? This thing that I'm clicking on, is that the actual sun?
Dude, I don't know for sure, but what I'm
I thought you had a
right now-
model. I thought you would be able to answer questions based off of the model.
I told you to clear your cookies because you did it wrong. You have to clear your cache now because you
so wait a
enabled
minute.
the
So
wrong
is that
settings.
the sun or no?
That's not the sun that I'm seeing right here. Because
I'm just asking, like, is this the real sun? Is this like in your model? Is that like where the actual sun is at this time and day?
There is what's called the real position of the sun and the apparent position of the sun.
Yeah. So like, so the actual sun is there, right?
I'm showing you on my screen.
Is
Look,
this the real position of the sun?
it might be.
Okay, so if that's the real position of the sun, now is this the real position of me? This like this little place on is that the real position of me?
Man, you were clicking so many buttons. I don't even know what you did. That's why I told you.
I'll just put myself where I actually live, right? So is this the real position of me? Right about.
I'm assuming you don't live in the ocean, so I'm gonna guess.
Sorry,
no.
I don't know why. Okay, there we go. It's close. Is this the real position of me? Like that where that dude is standing?
That's where. Well, there's a
That's
default
the American
position.
Southwest. That's where I live.
That should be it then.
Okay, so that's the real position of me. And so this is on, it's like, you know, whatever day, whatever time. It's clearly nighttime. But the sun is right there. And like looking at it from the side, like the sun is just like right there. Why can't I see it?
I'm gonna show you. Okay, what you
Why
gotta
can't
do
I see
is
the sun?
go to the bottom right and see search body. Look up search body.
Well, no, why can't you just answer my question? Like, I'm here, the sun's there. It seems like I have a direct line of sight to it. Why can't I see it?
Dude, you were clicking so many buttons and now you're trying to strawman me.
This is literally a question. I'm not. It's impossible for me to strawman you with a question. I'm just asking you why I can't see the sun.
That's not true. You can ask. Somebody can ask a sarcastic question to strawman someone. No,
My
I'm trying to
question's
help
not
you.
sarcastic. So why can't I see the sun? If I'm right here, there's my dude. It seems like I should have direct line of sight to the sun, right? Like there's nothing blocking it.
But don't you see the dome that you're in, the personal dome?
Yeah. But is that like a real thing that like physically that like blocks me from seeing the sun?
It's not a real physical glass dome, but what it is that's
so then
the
why can't I see the
perspective
sun?
and angular. That's perspective and angular resolution that you can see.
But
from
why
your
can't I
current
see the sun?
perspective.
What's stopping me from seeing the sun?
Well, what you would see is the sun. It would be in the dome, and so you can try and find the
why
dome.
can't I see the sun? Like what? Like look, the sun is there. It's emitting light in all directions. Presumably, some of that light gets to my eyeballs, right?
Well, I mean, you're in nighttime right now, so no. You gotta wait till you're.
So what is stopping the sunbeams from going from the sun to where I am?
Well, I want to clarify. We don't actually know if that's the height and elevation of the sun. This is.
So this isn't a model. So on this model, the sunbeams.
It is a conceptual model that is
okay,
not.
So if the sun were actually there, then you agree that I should be able to get the sunbeams directly from the sun, right?
If you were in daytime, yes.
Well, no, I mean in nighttime, where I am right now at this time.
Well, obviously we know that's not true because that's not how
so
day
then
and night
what's
works.
stopping the light? What's stopping the light beams from the sun
I'll show you.
from getting to the my eyeballs?
You gotta press your space bar, man. Okay, see, this is what I'm talking about.
I have no idea what's happening.
This is why I said you messed it up. You gotta clear your cookies in your cache because now you got.
Okay, I'm gonna clear my cookies. Don't worry.
And then refresh the tab.
This last hour or so.
Don't show your browser history.
Okay, so I cleared my cookies.
Yeah.
Okay, so here I'll move myself so that.
Oh, you gotta open you gotta reopen the tab, man. It's not just clear your cookies. You gotta.
Just did it.
That don't look.
So
right.
Now it's daytime. Okay.
Wait,
well.
actually, the sun's moving like normal. That should be right. Yeah.
Yeah. Okay. Right. Okay. So let's wait till nighttime, and I'll ask my question again.
All right.
So it's evening. It's evening, and now it's nighttime, right? It's nighttime.
Yeah.
So if this model were true, then the sun would actually be here, right? And I would actually be here.
Possibly.
Well, if the model's true, then of course it's actual. If the model's not true, then they could be wrong.
I need to reiterate. This is a conceptual model. It's still in progress. It's a work in progress, but we're getting there.
Okay, so conceptually, if the sun is anywhere above the disk, there should be a direct line of sight between the sun and my eyeballs.
But you see the dome? Can you pan your the dome?
But that's not a real thing. Right? It's not like it doesn't block light.
It's not a real dome, but what it is saying is that is the angular resolution from your exit Y coordinate position.
You can talk about angular resolution, whatever. The point is light from the sun has a direct line of sight to my eyeballs. What's stopping it from getting there?
Now, I actually believe that the sun is lower than that. I think that is
okay. Suppose the sun is lower, regardless of where the sun is above your pancake, the sun will have a direct line of sight to my eyeballs.
Well, we know that's not true because we know that's not true because that night and day, depending on the season, half of the Earth is illuminated in darkness.
Because because the Earth is a globe, my guy.
Well, they can work on different models as well.
No, it can't. I mean, unless you have an explanation for why the sun rays. Do you have an explanation for why the sun rays can't get from the sun?
Now look,
to
man,
my
I'm trying to show you when I find my dome. Can you go to search body and then look up the sun?
Look, I just need an answer from you, and then we can do whatever you want.
But I need to show you this first. When I'm in first
no, you
person,
don't. You need to answer the question first.
You will see the sun move up and down below.
What you need to do is you need to answer the question first.
What's your question?
What is stopping the sun rays, sun being here, from getting to my eyeballs?
Your eyes can't see forever, and the sun is not as big as the realm that we inhabit. The realm's very big.
My eyes can't see forever?
Of course
I'm sorry.
not.
So just as a question, the Large Magellanic Cloud, or let's take any of these stars that we can see. We can see the stars, can't we?
You can see the stars in your personal dome.
So why can I see the stars if they're basically the same distance away? They're obviously less bright, so why can I see them?
No, they're not basically the same distance.
They are. Like this star would be further away.
Blitz. I want to get a top-down view, aerial view, bird's eye view of the stars and the domes. You can see the stars. They are really far apart on the realm we inhabit. They're very spread out.
Yeah, we're looking at a top-down view. But like this star is further away. This star is like the Large Magellanic.
And that's why you can only see some of those stars from the southern part below the equator. That's why
Wait a minute, but the stars are quite. So you're saying that I can see up to these stars, but I can't see the sun?
You can see up to the stars in the personal dome because you can change your continent location in the bottom left, and you'll see
But look,
the personal dome changes.
Look, I don't know about you, but I can see like Venus and Jupiter, like these planets are like the same distance to the sun, right? And in fact, the only time that you can see Venus and Jupiter is like shortly after sunset or shortly before sunrise. Or Venus, rather, not Jupiter. Jupiter can be out in the night. But the point is that it doesn't make sense to me. Let's speed this up just so then we can get back to nighttime. It doesn't make sense to me that somehow we can see Venus, which is basically the same distance away as the sun, but we can't see the sun.
You can see the sun every 12 hours though. So
why can't I see the sun? Why can't I see the sun right now in this configuration? What's stopping it?
Or you're in North America, right?
Yeah.
Yeah, the sun is just too far away. It's
what's
it's
stopping
in Asia.
the light from getting to me?
Light can't travel forever.
What's stopping it?
What's stopping it is the light source that it's coming from is not big enough and high enough to illuminate the entire realm at once.
Look, so you agree that light goes in all directions from the sun, right?
Yeah.
Okay. So the light that is going towards me, if it's going in all directions, then at least one light beam is going towards me. Right? Because that's all directions. What is stopping that light from getting to my eyeball?
It's not big enough. The light source that it's being come from
the light doesn't know about how big the sun is.
Well, physics would dictate that the rays from the sun, it's gonna match the size and ratio. Yeah, it's gonna match the size and ratio of the light source to the illuminating plane.
So if this was an issue of size, then it wouldn't be the case that the sun is basically, and it's not exactly, but it's basically the same size right before sunset as it is at noon.
Well, we've actually measured angular size changing up to 50%, Blitz. And now
Here, let me show you a video of the exact opposite. So look, I agree that if you have significant, and by the way, I think that video that you're talking about, the 50% is actually fake, but if you're thinking
fake with a FLERF.
Well, no, if you're talking about the one that I'm thinking of, then it's actually been proven to be fake. But I want to show you a time lapse of an entire day. Is it this one? No, it's not that one.
What do you think about it being called the heliocentric? You know what Helios? You know who Helios is?
It's just the Greek word for sun.
No, it's a Greek pagan god.
Yeah, the pagan god was named after the sun. So this is a 12-hour from sunrise to sunset of the sun. So what they're doing is they're just pixel matching for a camera. We're just recording the whole thing, and then they're just putting a circle around it, like the circle that contains the whole thing. And so right now it is like 8:15 in the morning. Oh, I'm sorry, horizontal can't see it. It's like 8:15 in the morning, and we can skip ahead a little bit. It doesn't change in size throughout the course of the day. It doesn't change in size at all. It's 684 pixels across the course of the day. Now it's noon. It's still 684 pixels. Now it's 3 o'clock and it's 684 pixels. Now it's 4 o'clock and it's 684 pixels. 5 o'clock and it's 684 pixels. So if the sun was quite close and this was an issue of the size of the sun getting too far away so that we can't see it, we would expect the size to change dramatically over the course of a day. But let's see what happens as we continue on. So now it's 6 o'clock. Right, so we're going to see a sunset here in a minute. But keep in mind, the diameter is still 682, 684 pixels, which is what it's been the entire day. Hold on, we're almost there. So notice how it's getting yellower. That means we're approaching sunset. Of course, we're using a solar filter here. That's why you can see the sunspots. Notice how it's shrinking in the vertical axis. Like, see how it's touching on the sides, but it's not touching in the on the vertical. It's kind of like
that was
compressing.
Not the video I was gonna pull up, man. But what I was gonna say
is this is an atmospheric effect, right? So, but the important point is that even here, the width is still 670 pixels. And of course, as it goes smaller, you have to encapsulate it in something bigger, in something smaller. But even before, like even here, sorry, there we go. Even here, it's 680 pixels, which means this is right at sunset. This is right as it's supposed to be leaving our line of sight. It's supposed to be leaving our field of view. It's supposed to be getting too far away to see. How is it still the exact or nearly the exact same width right before it leaves our view? And then 30 seconds later, it's just too small to see. How does that work? Where's the smooth continuous behavior there?
This is fallacious because we don't know what tropic this video was taken from.
It doesn't depend on the tropics.
It does.
It doesn't.
The amount the sun would change depends entirely on
which
wait a minute.
Was your name Vril Kane?
I have a video to show you. See, this is what the video.
Oh yeah, that was the Nazi. Yeah, I shouldn't platform him, but he will go on YouTube because he's, we should make fun of Nazis. I totally forgot. Yeah, I don't recognize the voice, but no. So he was on my live stream as Vril Kane at one point, and that's when we exposed that he was a Nazi. And then he was on as Dark MAGA. So, I mean, yeah, he did open with anti-Semitism. That's true. Anyway, let's read some super chats. God, my jaw's really hurting from the sinus pain. Grandma's sweet. I can't read that. Thank you for the $5. When they talk about perspective, the perspective is changing with the picture, keeping the tree and the gazebo equal distances from our perspective. You talk about the perspective is changing with the picture. I don't understand. From Jessica Transmetal Alchemist with the $10 Australian, boiling water being hotter than oven air. At first, it seemed counterintuitive. We investigate further and discover deeper rules of reality. We don't demand that reality must conform to our intuitions. That's true. Boiling water is indeed does feel hotter than oven air. Why? Well, that's what we have to study thermodynamics for. From Binary Ghost with the $5, I see there is another fan of the 1946 classic Disney movie Song of the South. Unfortunately, Disney stopped releasing it in 1986, demanded on Disney+. No, let's not. From Jessica Transmetal Alchemist with the $5 Australian, this conversation has a strong put it in H energy. Yeah, it did. From Jack Fetter with the $5. Welcome to their new model. Just like Joe Hambian's model, this one too will soon never be mentioned again. Hashtag, but we do have a model. Hashtag Flat Earth Be Dumb. Yeah. So the moment I started asking questions about his model, he said, "Oh, but it's a conceptual model. Oh, but it's a conceptual model." From Gretchen with the $5. Well, it's freaking hilarious that on his model the Earth is flat, but all other bodies are depicted as globes. I love FLERFS. Yeah, no, I mean, they think that there's like domes and globes and stuff that rotate and stuff all around us. From Bacon and Bush with the $10, but I would not feel so all alone. Everybody must get domed. Oh, I feel like this is a song reference that I missed. From Binary Ghost with the $2, domain expansion flattened Earth. Good reference. Good reference. From Peter Hegwood with the $2, I did not see that coming. Me neither. I mean, I kind of did. You kind of have to. But guys, we are at the end of the live stream. Let me just double check, make sure I didn't miss any cash apps or anything. But it is time because I need to go take some Advil too. From Grimlock with the $15 on Cash App for No Clouds is Blasphemy. Don't forget to hydrate. Oh, where's my water bottle? Oh, there it is. That's what happened. I forgot to hydrate. Much appreciated, Grimlock. Thank you for reminding me to hydrate. And yeah, okay, so that's everything. We are going to end the live stream here. We will be live tomorrow with Ask a Physicist lives, not doing live streams or not doing debates, but just Ask a Physicist. So remember to tune in. If you want to support me, make sure that you go to my website and check out the support me little blurb at the bottom right hand corner of the website. You'll see it on every page, and you can also see my research, my outreach, and all of those sorts of things. We have a few more super chats. One from Ragnarok with the 50 Mexican dollars. Vril and Tartaria mentions in a single stream. We just needed some Hotep to complete the trifecta. Yeah, Vril Lord Kane was that guy's name, I think. From Nathan Irvine with the $5. Still no model that explains day and night and seasons. Yeah, I mean, like, they can't account for why the sunlight doesn't get to us. It's very strange. From Bacon and Bush with the $2. Beatles, Everybody Must Get Stoned. I haven't heard that song, but I have heard a lot of the Beatles. And from El Jazan with the $20, which is enormous and very appreciated. Welcome back. I can't even with these FLERFs. I often skip Galilean relativity in my intro course because the notation can be confusing. I initially teach it as a vector addition, then revisit the concept later in the course. Yeah, so I taught vector addition. I guess I just didn't cover it, which is weird, but maybe I covered it in a later semester and I just pulled up the wrong notes. And we have one final super chat from Mr. Pacho with the $20. Always appreciated. Always good to see you. I watched On the Level last week because I hate myself, and I think I'd still rather listen to a bunch of guys in MMA gear talk about why there's a firmament than hear a Nazi beg you to clear your cookies. That's so funny, though. He was begging me to clear my cookies. That was wild. All right, y'all. We are genuinely ending the live stream here. So take care, everybody. I'll see you guys tomorrow.